Welcome to Imarticus Learning. It's my pleasure to introduce our expert trainer Utkarsh Tiwari, who will lead today's masterclass on step-by-step guide to master prompt engineering for AI. In this session, you will dive into fascinating world of artificial intelligence and discover how to craft powerful prompts to unlock the best results from models like DALL-E and ChatGPT. Utkarsh will guide you through how large language models work, how they respond to prompts, and share advanced techniques for fine-tuning your inputs. By the end of this masterclass, you will not only know how to interact with artificial intelligence effectively, but also stay updated with the latest advancements in the field. Whether you're a beginner or looking to refine your skills, this is the perfect session for you. Let's get started.
All right, see how you are supposed to, take the advantage of this session or let's say, utilize this session to the best of your understanding. So first of all, let's say the first half is going to be mostly theory, all right? It's mostly going to be theory. We are going to understand the essentials of LLMs and let's say stuff related to the same. And the second half is going to be the practical part. All right, and as far as the practical part, where we'll be, let's say, creating a chatbot. For the practical part, we are going to create a chatbot. Now, these days, whenever you, let's say, if you are applying for any machine learning or let's say deep learning related role, majority of you, or let's say the chances are high that you might end up getting an internship at assignment or let's say a project based on chatbot where you need to create a chatbot based on LLM, right? So to cater to that requirement, it's imperative that you understand whatever we are discussing in this session, all right? So as far as the theory part is concerned, we'll discuss about the LLMs and stuff, and the practical part will be on chatbot building. So few essentials that you, let's say few prerequisites. So of course you need to have Jupyter installed, let's say Jupyter or Anaconda. Then let's say you need to have VS Code. We'll be working on VS Code, and you need to have Python installed in VS Code as well. All right. Next, so I just want a confirmation from you all whether you're using, let's say, ChatGPT using the same Gmail ID, or is it using a different Gmail ID? I'm asking this question because suppose you're using ChatGPT from the same email ID using which you have logged in as of now. So most likely your $5 free credit might have expired, right? So if it is same, do one thing. Maybe you can create another email ID, another Gmail account, where you'll end up getting $5 free credit. That is how you'll be able to utilize it. See, we need to set up OpenAI API key, right? We need to set up OpenAI API key. Now, whenever you, let's say, sign up using new Gmail, we get $5 credit. All right. So most likely, if you're using the same email ID, you won't end up. You might have utilized your $5 credit already. So either you can log in using a different Gmail account or create new Gmail account if needed. All right. Or you can create a new Gmail account if needed. All right. So these are the things required. So we need an OpenAI API key. And in case this is not the case, then let's say, otherwise you need to make payment. You have to make payment for the same if you're supposed to implement this. All right, I've already set up my account. It might have exhausted as well, so I'll just check it up. Otherwise, I'll make the payment for the same. All right, so these are the prerequisites as far as the practical implementation is concerned. All right, I'll be sharing all the files towards the end of the session, as in Jupyter, and yeah, one more thing, we need MySQL as well. MySQL workbench, and maybe shell. These are some additional requirements. See, we are going to create, we'll be creating two, let's say, chatbots. See, you can use the past account provided you have not utilized your $5 credit. If you have already consumed your $5 credit, then you might need to create a new, let's say, Gmail account, or maybe you need to make the payment. All right, or you have to make the payment. So please ensure that you have, let's say, VS Code installed, MySQL installed as well, and let's say Jupyter, I'm assuming, is already installed in your system, right? So these are the prerequisites. So the let's say objective of this session is let's say whenever you are applying these days for any ML or let's say TL based role, so you do come across multiple let's say chatbot related maybe internship assignments or maybe job related assignments, right? So you must have a fundamental understanding about how we are going to create chatbot in the first place. Let's say what all it takes to generate a chatbot from the scratch, and maybe let's say so we do have the concept of multimodal architecture. We'll have a discussion about the same as well. So that depends on the token. That depends on the token that how much tokens you have utilized. All right. It completely depends on your usage. Is it clear? All right. So guys, over here I'm going to let's say switch to the PPT part. Yeah, the recordings will be provided maybe after a couple of days, maybe tomorrow or day after tomorrow. All right. So assuming the screen is visible and I'm audible, I'm getting started with the session. So those who have joined later, guys, again, I welcome you all to this masterclass on building chatbot using LLM. So let's have a look at the agenda for this session. So first of all, we are going to understand the basics of LLM. All right, moving forward, we are going to understand why LLMs after ML and DA. So there's another basic prerequisite which I missed that is not meant for the practical part, but for theory part. You must have some understanding about machine learning and deep learning, right? I see. So I'm assuming everyone present over here has some understanding about machine learning and deep learning. If not partially, we are going to have a discussion about the same. All right. So when we are talking about LLMs, we are talking about a concept, let's say, uh, which is considered light years ahead compared to something known as machine learning, and much further, let's say, advanced compared to something known as deep learning, right? So we'll have a discussion about ML and DL as well in brief. And then we are going to understand how to generate and set up API key for, let's say, OpenAI and Gemini. All right. OpenAI being the, let's say the majority of the projects that you'll come across these days, they do come from OpenAI. So we can utilize, we'll be utilizing OpenAI, but I'll also show you how to set up, let's say, API key for Gemini. Then we are going to understand the role of vector database. All right, we are going to understand different types of vector database that we have and the commonly ones which we are going to use. Then a very important concept that we'll be, let's say, discussing, that is going to be RAG. All right, and we're going to understand why to learn chatbot building in 2024 and what was the scenario before, let's say, LLMs came into picture. How the chatbot building has transformed, let's say, over the years. Then we're going to understand the steps for building the chatbots, utilizing LLMs. And then let's say we'll be building chatbots using LLMs, maybe chat with PDF, chat with database. And if time permits, we can go through some other multimodal chatbots as well. All right. So guys, is the agenda clear? Screen should be visible. You can check. All right. So guys, I hope the agenda is clear, right? All right. So as discussed, first half is going to be mostly theoretical, and then post let's say 12 or 12:30, we can proceed with the implementation, the practical implementation, right? All right, so I'll show you the documentation as well. So where we can have some better understanding about let's say LLMs and LangChain and what all things are required. All right, so let's have a look at the takeaways. So the objective over here is that let's say you can understand better, you can understand the concepts of LLM and their applications. All right, you'll be able to master the essentials of chatbot building. So you'll understand the fundamentals and what all things it takes, and let's say partially how it works. All right. See, when we're talking about deep learning and let's say concepts beyond deep learning, essentially we are digging into the domain of black box models. All right. So the practical implementation won't give you an idea exactly how they are working. Then another takeaway is you'll be able to let's say create a RAG-based chatbot with PDF from various domains. So I do have PDFs from let's say some horoscope related PDFs, some budget related PDFs. All right, so we can utilize that. Maybe we can use some medical, let's say, healthcare related PDF as well. And then we are also going to build a chatbot that interacts with MySQL database. So for that, we can pick up any data set, let's say from Kaggle. All right, we can store it in a database. And then we can, let's say, query that database in the table utilizing the chatbot. And there's one more thing that will be required. That is going to be Streamlit, right? So guys, basically, even in the previous master session, we have worked on, let's say, chat with PDFs. But over here, we'll be creating an entire application, right? In the previous master session, what we discussed was mostly based on Jupyter Notebook or I guess Colab. But as far as this session is concerned, we'll be creating a chatbot as in a complete chatbot. So we'll be utilizing Streamlit. So in case you guys are not familiar with Streamlit, so there has been a previous masterclass on the same. All right, so I hope some of you might have gone through the previous masterclass as well. Guys, have you guys attended the previous masterclass on let's say Hugging Face and Streamlit? All right, so guys, those of you who have attended, they have some idea about Streamlit and how to utilize Streamlit. So Streamlit is essentially a framework. All right. All right, no issues, no issues. So as of now, see, those of you who have not attended this, we just need this framework, right? It is a Python, let's say, framework used to create web applications. See, when you are interacting with ChatGPT, you are running it in a browser, right? You are running it in a browser. So likewise, we need to create a web application. So for web application, we need to have Streamlit framework. So those of you who have not attended this session or let's say Streamlit is not installed, what you can do? Over here, you just write in Jupyter, you can just write if install Streamlit. Just execute this. Just execute this, or maybe we'll be creating, let's say, a virtual environment and we'll be installing certain dependencies. So either you can install now, or maybe towards the second half of the session, we'll be again installing it. Is it clear? This is another requirement. We need to have this framework, all right? This is the framework on which we are going to build up the chatbot. For both the chatbots, let's say the PDF one and the one with the SQL, we'll be utilizing Streamlit along with demo. Okay, see the installation part, I guess, means if you have covered through machine learning. So I guess VS Code and Jupyter installation, this part we can, you can do it on your own, right? This will be discussed. All these things will be discussed. 3 and 4 will be discussed. All right. If you have covered through machine learning, so I don't think installing Jupyter or VS Code or MySQL should have been an issue for you. All right. Streamlit we are going to install. And OpenAI API key, how to set it up. This we are going to discuss. That's in fact even an agenda for the session as well. How to generate and set up API key for OpenAI. This we are going to discuss. Clear to everyone? All right. So guys, these are the key takeaways. means see, we'll be discussing with MySQL, but it's not mandatory that you use MySQL only. You can connect with, let's say, you can also connect with Postgre. You can connect with SQL Server. You just need to have the connection string, right? You just need to have the username, password, the host name, and the port number, utilizing which you can connect to these different database. I'll show you the documentation as well. All right. So let's say when we are discussing about LangChain, so we'll have a look at the documentation as well, right? See, documentation, make it a practice to go through the documentation. Yeah, that gives you an idea about how, let's say, things are working in the background. All right. What are new functionalities? What are the new classes that, let's say, that are coming up as far as a particular documentation is concerned? Documentation is of much concern, especially we are dealing with advanced concepts, highly advanced concepts such as LangChain or LLMs. So I'll show you the documentation as well. How to all right, just yes. See, what was there in the LangChain maybe 2 years down the line is now no longer utilized. So that is why going through the documentation is imperative. All right, a lot of new things are coming up. A lot of new things have already, let's say, been utilized in the industry previously, which was not present. So I think everyone is joined. Right. So do we have more students waiting? No, right? Okay. So we are getting started about it. So guys, just have a look. Let's understand LLMs in the first place, right? See, LLMs stand for large language models. So LLM is a type of, let's say, artificial intelligence model designed to understand and generate human-like text based on large-scale data sets. LLMs, as in the name itself, is comprised of large language models, right? So LLMs, let's say, they are trained on very large amount of data. When we are talking about very large amount of data, we can expect data in the range of maybe petabytes or even more, and even zettabytes. All right. Let's say we can consider that these LLMs are trained on the entirety of the internet or a majority of that section as far as the training part of LLM is concerned, right? So we are talking about a highly advanced AI capability or AI technology that is capable of generating human-like text based on, let's say, large-scale data sets. All right. So obviously, the objective over here is to generate human-like text based on large-scale data sets. So LLMs are trained on vast amounts of data, of text data, allowing them to learn the intricacies of language, including grammar, context, and even subtle nuances in tone or even the intent. So let's say those of you who are familiar with deep learning, so you do understand, right? Let's say we might end up facing certain challenges when it comes to text classification, let's say for sarcastic comments. If you're supposed to analyze or let's say predict the tone or sentiment for sarcastic comments, that is where even deep learning models may falter. Are you getting the concept? Are you able to understand what do we have on plate when we're talking about LLMs? As of now, let's just understand that it is a highly advanced AI model that has been trained on an extremely large data set. All right, with the sole purpose of, let's say, understanding and generating human-like text. The way we, let's say, interact, let's say, the way we converse, that is what, let's say, can be assumed as the end goal of an LLM. All right. Now, to better understand LLM, we'll further take it down. So a large language model is a type of artificial intelligence algorithm that applies neural network technique with lots of parameters to process and understand human languages or text. So guys, are you familiar with neural networks? Are you familiar with neural networks? All right. So when we are talking about neural networks, right? I'll give you a brief idea. Those of you who are not familiar, see, when we say we are talking about a neural network, right? So the way we have neurons in our brains, right? The way we have neurons in our brain, how does human brain perceive a particular information? First of all, we receive certain stimulus or some input. Then the nerve cells undergo certain pre-processing based on that input, and then a response is propagated. Are you getting this? And then a response is propagated. So this is, let's say, a general architecture of a typical neural network. This is how, let's say, we can assume a neural network looks like. So we do have, let's say, a couple of neurons. This is referred to as the input layer. Then we can have multiple hidden layers, and we can have one or multiple output layers. And these input layer, hidden layers, and output layers can be, let's say, realigned to fit a particular problem statement. They can be programmed and they can be customized to fit a particular problem statement. All right, so this is just a very fundamental or a very basic neural network. This is just an architecture. When we are talking about actually implementing a deep learning problem statement in the industry, essentially we'll be dealing with a highly complex and most likely a deep neural network where we'll be having multiple neurons to begin with. All right, multiple neurons, multiple layers, and multiple, of course, and multiple output layers as well, depending upon the kind of problem that we're dealing with. Now, so deep learning can also go to, let's say neural networks with very high, large number of neurons or neurons, let's say neural networks with high number of hidden layers, right? That is referred to as deep neural network. Now, going further beyond that, even when we are training a neural network or let's say a deep learning model, right? So essentially, we do come across, let's say, architectures where we do have, let's say, when we're talking about trainable parameters, right? We talk about something known as trainable parameters. This number goes into, let's say, it can go into thousands, and it can even go beyond that, right? So usually this is the case with neural networks. This is the case with neural networks. So the number of trainable parameters that we have in neural networks that can go into thousands and even lakhs and even beyond. Are you getting this? But when we are talking about something known as LLM, right? So the number of trainable parameters that we have over here, they start from billions. Are you getting this? The number of trainable parameters that we begin with, they start from billions when we're talking about, let's say, LLMs. So just think about the complexity, think about the architecture of the LLM, right? Now, when we're talking about trainable parameters, for those of you who are familiar, we are essentially talking about weights and bias. So the sum total of, let's say, weights and bias for, let's say, a very basic neural network can go up to thousands and even lakhs and even more. But when we're talking about trainable parameters for LLMs, all right, the starting point would be some billion, all right, some billion number. So if I were to show you what is this number that we're talking about, so let's just take parameters, all right, in GPT-4. Just have a look. How many parameters are we talking about? How many parameters are we dealing with when we're talking about GPT-4? We are talking about 1.76 trillion parameters. That is the number of trainable parameters that we do have in GPT-4. All right, okay, let's go to GPT-3. So GPT-3 comes up with 175 billion parameters. That is the extent to which it is capable of expanding its learning. See, the more the number of parameters, the better the model is capable of learning, the better the model performs in terms of its metrics, be it accuracy, be it some advanced metrics like blue score, etc. All right, then we have 3.5. So it is saying somewhere around 175. But let's say now the GPT-4 being in picture. So over here we have 1.76 trillion parameters. Just think of the amount of data that it might have been trained upon, that it is capable of generating, and it is capable of being trained on 1.76 trillion parameters. Are you able to, let's say, understand the picture on a larger scale? What is the kind of data or what is the kind of learning that we're dealing with? Guys, are you able to understand the scale at which we are referring to? The training, the learning part, it's extremely huge, all right? It's extremely huge. So that is why when we are dealing with, let's say, deep learning and even LLMs, we are talking about black box models. All right, we won't be able to see what is happening in the backend. We won't be able to understand or comprehend what is happening in the backend. At the max, you can go through the documentation and let's say maybe practice the same concept with a couple of different data sets, couple of different maybe architectures, and then you'll be better able to understand the concept. Yes. All right. So when we're talking about LLM, so LLM is a type of artificial intelligence algorithm that applies neural network techniques with lots of parameters to process and understand human languages or text. Now, if you are familiar with deep learning, you might have an understanding that the larger the amount of data, the better the model performs. That is why when we are training deep learning models, it is advised or recommended to utilize a GPU. Rather than working on CPU, we do utilize GPU as far as the deep learning models are concerned, right? So even for LLMs, let's say it is advised or recommended to utilize GPUs. All right. But as far as the web applications are concerned, it's not everyone might be having a GPU-based system. So that is why we do have Google Colab, right? In Google Colab, we can utilize the GPU, but only one session at a time. So if at all you wish to, let's say, implement LLMs on your own, so try to utilize Google Colab, right? There you'll be able to implement all the things, except let's say for the web app part. And even we can implement Streamlit or maybe Flask in Colab as well. We do have certain frameworks for conversion. So for Jupyter, if you need to run it on GPU, you must have, let's say, a graphic card installed in your system. You might be having, let's say, NVIDIA or CUDA based graphic cards. Then you'll be able to set up GPU in Jupyter. Now, let's extend the conversation further. Yes, as I mentioned, the recording will be shared, right? The recording will be shared by tomorrow or maybe by day after tomorrow. So let's extend the conversation. So LLM, as discussed, is a type of artificial intelligence model designed to understand and generate human-like text based on large-scale datasets. Now they're trained on vast amounts of text data, allowing them to learn the intricacies of language, including grammar, context, and even subtle nuances. Large language model is a computer program that learns and generates human-like language using a transformer architecture trained on vast training data. Now, transformers, let's say 4 to 5 years back, or maybe around, let's say before the onset of ChatGPT, transformers were considered to be the, let's say, pinnacle of AI. All right. Transformer models were considered to be the pinnacle of AI. All right. Because transformers model were capable of performing all the, let's say, highly advanced functionalities of AI that were otherwise considered quite complex. Means just understanding transformer model itself is, let's say, kind of gigantic task. I can show you a couple of papers. To understand transformer models, you must go through this documentation. Now, this is the starting point, let's say, where LLM stems from. If you need to understand the background mathematics, all right, you must go through this documentation. So, over here, you'll find a highly complex architecture. Keep this in mind, this is the starting point. If you need to understand the mathematics of LLM, how the LLMs are working, how they are trained, all right, and how they are able to generate the predictions, we'll have a brief discussion about the same as well. But this documentation is a must go through documentation if you wish to understand transformers and if you want to deep dive into the mathematics of LLMs. So this is a typical architecture of transformers. All right, and I can share you this link. So over here we have some input embedding, then we do have some multi-head attention, then let's say the feed forward mechanism. So over here we have positional encoding. This part of the architecture is for input, and this is where we do end up receiving the output. All right. So this is we have multi-head attention. Over here we have masked multi-head attention. So you need to go through this documentation. Means there are simplified versions of this documentation available as blogs, available as videos, just to help everyone explain and understand the concept of transformers, how they are working, how they are trained, how they are optimized, how to tune them, and everything else. All right. So consider this as the starting point or the beginning of where we can proceed with LLMs. All right. So I've shown you just the transformer architecture. Right? This is one of the most complex architectures as far as any deep learning model is concerned. Compared to any deep learning model, unless and until it is an advanced version of transformers, this is the most complex architecture prior to ChatGPT and LLMs. All right. We are talking about let's say era or time zone prior to ChatGPT. At that time, transformer was considered one of the most complex architectures compared to any other deep learning models. Let's say parallelly and equivalent to maybe reinforcement learning, complex architectures of reinforcement learning. I hope you're getting the context that let's say LLMs means you just have a look, you won't be able to understand it, how they are working, because essentially they are the black box model. Okay. Right, I'm sharing this link in the chat. Yeah, I've shared the link in the chat. So you need to understand the attention model and the transformer models, let's say to further understand how the LLMs are trained, how they are working and stuff. All right. So when we're talking about LLMs, right? So LLMs use deep learning algorithms to process and understand natural language. All right. Now LLMs can perform many types of language tasks. So what are the tasks that we can implement using LLM? Let's say some common tasks are translating languages, analyzing sentiments, chatbot conversations, and more. They can even understand complex textual data, identify entities and relationships between them, and generate new text that is coherent and grammatically accurate. So this defines the, let's say, applications of LLMs. Right? This point defines the application of LLM. Think in terms of the industries. Think about the industries that do utilize chat-based applications. All right. These days, or let's say from quite some past years, we do get to see different chatbots do pop up on websites like, let's say, Zomato, IRCTC, Ola. They all have their chatbots, right? Now, since the onset of ChatGPT, maybe from 2023 and onwards, you might have seen some AI-based features on these chatbots. Yes, have you seen these AI-based features on these chatbots? Suppose you are querying Myntra or maybe you are querying Zomato. So prior to ChatGPT, we were only able to search for a particular restaurant or a particular food item, right? Yes or no? Now, if you open, let's say, if you have subscribed to Zomato Gold, are you able to search for even customized food options? Suppose I can search for healthier breakfast or healthy breakfast rich in protein. I do have such options if I have subscribed to Zomato Gold. All right. Likewise, I can search for a specific maybe brand or a specific type of maybe clothing apparel on Myntra as well. Have you explored these options? Have you explored these options? Suppose I want to, let's say, I don't want to go for a particular brand. I just wish to search maybe beach wear, all right? Beach wear or maybe party wear, formals. Formals is a common term. So you can explore certain nuances when we are talking about, let's say, embedding uh, LLM-based chatbots even on these platforms. So an LLM-based chatbot is capable of, I'll repeat, an LLM-based chatbot is capable of analyzing sentiments, translating languages, chatbot conversations, and more. All right, these days, let's say building chatbots and customizing them, fine-tuning them, optimizing them. Let's say industries are heading into these domains because they have, let's say, huge amount of data. They have huge chunk of data, right? And they want to, let's say, their clients or maybe their applications might have a requirement where they need to interact with the data, where they need to extract a particular information or relevant information based on a specific context. So this is where LLMs comes into picture. Even we can embed or let's say integrate maybe an image-based chatbot with a text-based chatbot as well. We do have those capabilities as far as the multimodal architectures are concerned. So try to picture them on a larger scale. Try to picture these concepts on a larger scale to have a better understanding, right? So LLMs are characterized by their large size, often having billions of parameters. We just discussed this. And we're talking about LLMs, we're talking about billions of trainable parameters, right? The scale of these models enables them to handle complex tasks and even generate more coherent and contextually relevant text. All right. So it's imperative to generate contextually relevant text. Now, I'm assuming everyone over here has utilized ChatGPT. Yes. At least once you have used ChatGPT. Yes or no? Okay. How many of you have seen ChatGPT falter? How many of you have seen ChatGPT falter at times? Have you seen ChatGPT generating, let's say, irrelevant responses? At times, even for the simplest of the questions, it ends up generating incorrect responses, right? Not always. I'm not saying always, but at times. And it's not just about ChatGPT. It's the same case with Gemini. It's not just ChatGPT that ends up generating incoherent or irrelevant responses. It is the same case with any, let's say, chatbot that we do have for free. See, what is freely available definitely is bound to be, let's say, not that great. Are you getting this? Why are we offered ChatGPT for free in the first place? So that we do understand its limitations, so that the OpenAI can sell their, let's say, the pro version to those who have already, let's say, understood or maybe who have already utilized the limitations of ChatGPT, right? So even though when we are talking about, let's say, grammatically accurate, we are talking about generating text that is coherent, still we do end up getting errors, right? So even a model or an architecture that has been trained on, let's say, billions of parameters, still it is capable of generating errors. So the state of perfection that is, let's say, essentially characterized by the metrics. When we're talking about any LLM, we do have certain metrics as well, let's say, to weigh the performance. And these days, if you have been following, let's say, any AI-based maybe blogs or maybe AI-based technological advancements, so you might have come across that every month or let's say every couple of months, there's a new LLM model that is capable of outperforming its predecessors. Yes. Every month, there's a new model that has been, let's say, outperforming its predecessors. So all of these companies, let's say tech giants, they're all into a great competition, right? So we have Google, we have OpenAI, then we have, let's say, Apache. Then there are a couple of other companies as well, right? We have Microsoft. They're all into the race of generating the best possible LLM, all right, or at least outperforming the previous best LLM. So there has been news circulating about GPT-5. All right, maybe by the end of this year or by the beginning of the new year, you might get a glimpse of the same. GPT-5 is on the way, and we might get a glimpse of the same in by the beginning of the new year, or maybe by end of this year. All right. So most likely, definitely by, let's say, by next year, we'll have ChatGPT-5. As far as the advancements are concerned, ChatGPT-5 is on the way. So think about it. When we have already discussed what is the number of parameters in GPT-4. So we do have 1.76 trillion parameters. All right. We do have a model that is capable of outperforming its predecessors based on 1.76 trillion trainable parameters. But still, let's say the state of perfection has not been achieved. Why each of these tech giants are coming up with, let's say, new LLMs or new, let's say, architectures? Because they claim, or let's say, it's not just a claim, means there has been proof for the same, that a couple of LLMs do have the capability of outperforming the other LLMs, right? In terms of performance, in terms of there are a number of metrics. Are you getting this? All right. So the scale of these models enables them to handle complex tasks and generate more coherent and contextually relevant text. Now, let's understand certain applications of LLM. And I think we have discussed this even in the previous masterclass that was around that was on prompt. So the applications remain the same. So we can utilize this in a couple of industries, right? We can utilize this, let's say, in telecom. So LLM powered, so these days we do have agents as well. So LLM powered agents for customer inquiries in any written voice channel. All right. So in telecom industries these days, you might have heard, let's say that suppose you call a customer care, right? Previously, there were, let's say, actual humans who used to cater to the queries. These days, we hardly find any humans catering to the queries, especially for, let's say, customer care support. Have you observed this? Guys, have you observed this scenario? These days, do we encounter real human, let's say, assistants who handle customer care support? Yes, means I'm not saying they have completely eradicated the system, but their frequency has declined, right? The frequency has declined. We have more and more, let's say, voice-based assistants, or maybe inbuilt app help section, where we can report our queries, and then it will generate a token, and then maybe within a couple of days, the token will be resolved. All right. So we do have virtual assistants to guide users in resolving connectivity issues. All right, utilizing images and videos. Suppose you buy a product from Flipkart or Amazon, and maybe the product is faulty. How would you get a refund? You'd have to upload the images, right? You'd have to upload the images. So LLMs are also utilized in banking. So automation of processes that require analyzing large quantities of documents. So this, it's analyzing large quantities of documents. Again, this can be done using an LLM. So we do have financial AI advisor. All right. Then LLM-driven financial advice tailored to individual customer profiles, which with better user experience. So as far as the banking domain is concerned, so they are coming up with AI advisors. So essentially, they are LLM agents that have been trained on the previous financial advices and the data. And that is how they are giving financial advisors to investors, to let's say promoters, to retailers, etc. The same thing applies to insurance as well. So automate claim processing with image recognition to assess damages. So you might have observed or you might have come across a situation where, let's say, we have maybe registered for a particular insurance, but at the time of claim, we do end up getting some issues, right? They deny that under a particular scenario, maybe the insurance was not regulated. So this entire process, let's say, can be automated. We can automate claim processing with large image recognition to assess the damages. Precise risk assessment, LLM generated personalized policy recommendations based on user data. So even the insurance industries are using the LLMs. Then as far as the airlines are concerned, so we can deploy virtual assistants for efficient customer service and other personalized travel solutions. And we do have image recognition for regular maintenance and safety checks. So as you can see, all these industries are utilizing LLMs. And it's not just these industries, we have other industries as well. We have retail industry. So as far as the retail industry is concerned, have you come across a situation, let's say, where the entire grocery store is monitored by an AI? It's not in India. You might have come across such videos on YouTube, maybe for a different country, where the entire grocery store is operated by an AI. Have you seen such videos? Means from payment to entry to purchase of the product to the transaction, everything is controlled by AI. All right, and even they do have the inventory management system as well. So that is where LLMs come into picture. So LLMs combined with multimodal architecture can generate out of, let's say, excellent results, right? So in the retail industry, and they enhance the shopping experience with personalized recommendations. They manage inventory through advanced image recognition. They analyze market trends using AI to forecast the demand. Yes, definitely. So we do have LLMs in healthcare as well. So they can assist doctors in diagnosing diseases with medical imaging analysis, and they can help the doctors to interpret medical images and reports for quicker diagnosis. All right. Now, they can assist doctors to develop, let's say, personalized treatment plans using the patient data. They can provide virtual health assistance for routine inquiries and patient monitoring. Now, there are a number of apps on Play Store that you might have seen that can give you a routine around your health, let's say wherever your health lacks. Yes, we do have a number of apps related to health that can generate a tailor-made output for your entire routine, for your entire lifestyle, for your entire, let's say, diet. Yes, have you come across such applications? They can generate your entire diet plan based on your health diagnosis. You provide them with certain details about your health, about your age, about your body weight, about your food intake, and about your routine. They can generate an entire health plan for you because they have been trained on such kind of data. So that is why we do have such applications in the first place. So again, there are, let's say, outcome of LLMs. Now, even in the entertainment industry, let's say, be it some OTT platform, all right. So LLMs can generate and recommend content based on a mix of user preference and behaviors. All right. Now, LLMs can even create immersive learning experiences by combining text, images, and audio. So even in the, let's say, education industry, LLMs can be utilized, and they have been utilized in certain education industries as well, right? So guys, I hope you have an understanding about the applications of LLM. Yes. Is this clear to everyone? Is this clear to everyone? All right. Next, let's have a look. Let's try to understand what are some popularly used LLMs. So as far as the GPT family, let's say they started with the chat GPT. So we do have, let's say, GPT 3.5. So that is the default GPT version that we are all using, provided you have not opted for the Pro. All right. Then we have GPT 4.0 and 4.0. Then we have Mistral, we have Claude, we have Llama, we have Gemini, we have Gemma. Other than these, we have a couple of others. All right. Other than these, we have a couple of others LLMs, right? We have a couple of others LLM. So these are the most, let's say, challenging and the promising LLMs that have come to the surface. There are a couple of other LLMs, let's say, that have not outperformed them. So you might have come across these names. Definitely, we are all familiar with, let's say, we have definitely come across the terms, right? GPT 3.5 and 4.0. So some of you who have been following LLMs, they might have come across these terms. We do have Mistral, we do have Claude, we do have Llama, we have Gemini, all right, and we have Gemma. So there can be other LLMs, and let's say every new month or maybe every 2 months down the line, we do come across new LLM that is capable of outperforming the previous LLMs, right? These are the common LLMs that we use. Now, suppose means as far as the practical implementation for this session is concerned, we'll be utilizing GPT 3.5. All right. Now, in case you wish to utilize the other models, so you can utilize them. So for that, you need to go through the documentation for Hugging Face. You need to go through the documentation for other, let's say, models as well. All right. Now, let's understand on the surface what it takes to train an LLM, right? What comprises of the training phases or how the LLMs essentially work in the backend. I'm just giving you an overview, right? I'm just giving you an overview. It's on the surface. This is just the surface level of the training part. All right. So the efficacy of an LLM comes largely from its training process. When we are saying that, when we're claiming that LLMs are so accurate and reliable, so essentially we are claiming that it's high on efficiency, right? So what goes into the training part of LLM? Let's understand this. So essentially there are 2 to 3 phases. Over here I've mentioned 2, but there's another phase as well. So there's a pre-training phase, there's a fine-tuning phase, and then there is RLHF. So when we talk about the pre-training phase, right? So over here the model is exposed. Let's say we are talking about LLMs. So over here the model is exposed to massive amounts of text data, such as books, article, or let's say web pages, or a major section of, let's say, internet, depending on the context. All right. So the model, let's say any particular LLM is exposed to massive amounts of text data. It can be books, article, or even web pages, so that it can learn the patterns and connections between the words. All right. The more data it is trained on, the better it will be at generating the new content. So we need to feed in with more and more relevant and contextual data so that it can, let's say, learn better. So by doing so, it learns to predict the next word in a sentence. Essentially, let's say when we're talking about LLMs, we have discussed this that LLMs are generative models, right? They are capable of generating human-like text. All right, we are talking about a model that is capable of generating human-like text. See, they generate human-like language, right? So essentially, they are all generative languages. So they have the capability of generating. Now, to be able to generate, let's say, words or responses, they need to learn to predict the next word in a sentence, right? This is where the ability to generate stems from. When we are talking about, let's say, text generation, so we are essentially talking about generating words in the first place, right? Text, the entire text comes from the word, and words do comes from the alphabets, right? So we need to generate words in the first place to essentially be able to generate the entire text-based responses. All right. So through billions of such predictions, the model learns the grammar, facts about the world, reasoning abilities, and even some biases present in the data. That is how, let's say, the pre-training works. In pre-training, the model goes through, let's say, we feed the LLMs with extensive amounts of data, all right, onto which the model is getting trained upon. Then the next part is the fine-tuning. Next part is the fine-tuning. So after the initial pre-training, the model can be refined on a narrower dataset to specialize in the specific task or knowledge areas. This helps in aligning the model's responses with the desired outputs. Are you getting this? Guys, can I get a response if these two, let's say, working of LLMs is clear to everyone? So there's a third point as well, which over here I have not mentioned. The third point is RLHF, reinforcement, let's say, learning with human feedback. Now, the response that we need should be in a human, let's say, comprehensible format, right? There's the response that you get out of ChatGPT. Are you able to comprehend it? Yes. We are able to, let's say, understand the response from ChatGPT or from Gemini. So this is where RLHF comes from. All right. This part of the training is referred to as reinforcement learning from human feedback. All right. Now, let's come to a very important question. Now, suppose you have covered machine learning, suppose you have covered deep learning, right? Now, why LLMs? Why LLMs after, let's say, machine learning or deep learning? It's not just because, let's say, it's obviously it's highly in demand, and let's say these days industries are looking for students or maybe let's say employees who are capable of working on chatbots, employees who are capable of working on LLMs, LangChain, Llama Index, all right, and GPT-based architectures. So let's understand this. So in this section, we'll be essentially dealing with the brief of machine learning and deep learning as well. So those of you who are not familiar can get some idea. At least I'm hoping everyone is familiar with machine learning. Guys, I hope everyone is familiar with machine learning. Yes. All right. So over here, let's get this started. So see, large language models after mastering machine learning and these deep learning is a natural progression. Means, see, suppose you have covered up machine learning, you have understood the fundamental concepts of machine learning. So let's say you are on step one. The next step would be to understand the fundamentals and the applications of deep learning with practical implementation. That is going to be step two. Then the next step would be the attention models, the transformers model, and maybe let's say frameworks like or libraries like TensorFlow and PyTorch, right? That would be the step three. And the step four, as far as let's say if you're stepping up the ladder, then the step four is definitely going to be the LLMs and LangChain or maybe Llama Index, right? So let's say understanding LLMs is a natural progression after having covered machine learning and deep learning that allows you to leverage the foundational knowledge and skills from the machine learning and deep learning to tackle much more complex and specialized problems in the field of NLP and even multimodal architecture domain as well. All right. See, LLMs means as of now, when we're talking about specifically, let's say LangChain and maybe Llama Index, so we can concentrate mostly on text-based models, all right, that generate text as output. But we are already living in the era of multimodal architectures. Multimodal architecture means, let's say, anything can be converted to anything. So previously also we have discussed this concept. And reiterate, when we're talking about multimodal architecture, right? So when we're talking about multimodal architecture, we are talking about text, image, audio, GIF, all right, maybe video, all right, web page, JSON, table, any kind of data. We are talking about this is set as input. This is the input to the model. This is the data on which model has been trained upon. And what is the output? Output can be any of these. Output can be any of these. This is referred to as multimodal architecture. This is referred to as multimodal architecture. All right. Now, ChatGPT 3.5 is essentially, let's say, text to text. You feed in certain text, you get response as a text, maybe at times as a table, maybe at times as a JSON file, maybe at times as a HTML file, right? So this is the privilege that you end up getting with ChatGPT. But suppose you want to generate a diagram. you want to generate a flow chart utilizing ChatGPT. So that is where you need to upgrade to the Pro version. So definitely you might have come across models, and previously also we have discussed in the master session. Uh, you might have come across Sora, right? So that is text to video architectures. So we do have audio to audio architectures, image to audio architectures, audio to video architecture. We have text to web page architecture, web page to text architecture. Means any of these can be input and any of these can be output. This is essentially what is referred to as multimodal architecture. All right. Now these days industries are more interested in integrating, let's say maybe text to text to, let's say, text to image or maybe text to video. This is the kind of architecture, let's say, that as industries are heading towards. Means a single, let's say, model or a single application that is capable of performing all the three. And then, of course, means you do have the privilege for Q&A. You can perform Q&A on this kind of an application. So this is already into the picture, right? This is already into the picture. Next, we are trying to achieve this. And of course, means once this application is ready, we can implement Q&A on the same. All right, this is one particular application. There can be multiple different applications as well. You can generate an API, you can perform, you can implement REST API, you can implement GraphQL. So there are a number of other applications as well. All right. So I hope this is clear. So the objective over here is to leverage the foundational knowledge and skills from machine learning and deep learning to tackle much more complex, specialized problems in the field of NLP and let's say NLU, natural language generation. Now, let's understand the fundamentals of machine learning. So when we're talking about machine learning, right, we have learned the core concepts and algorithms, including the supervised and the unsupervised learning. Yes, I hope everyone over here is familiar with the supervised and unsupervised learning. So in supervised learning, we do have labeled data, and in unsupervised learning, we do have unlabeled data, right? We do have unlabeled data. Yes, all right. So, see, foundation of machine learning is crucial when dealing with LLMs, as it helps you to understand that these models are built, trained, and optimized, following the same routine, the same pattern, the way, let's say, ML and DL have been trained upon. Means there are a couple of advanced complex nuances involved, but essentially the learning process, the procedure remains the same, right? So how these models are built, trained, and optimized, concepts like supervised, unsupervised learning, loss functions, regularizations, they're essential when working with any kind of model, including LLMs. Are you getting this? Guys, I hope you are getting this. Okay. So suppose over here, I do have an example. I'll show you the image as well. So how ML models distinguish between, let's say, two genres of music. Suppose we have reggaeton and R&B. And in case we do have a linear classification. So this is just an example. So just try to concentrate over here. Based on we have two different kinds of songs, right? We have R&B and let's say reggaeton. These are two different kinds of songs, and we are supposed to classify a song based on its energy and tempo. Based on its energy and tempo, we need to classify these two models, right? So essentially, what we are doing, we are generating a linear model. This let's say straight line separates the two classes, the two different classes that we have based on their features like energy and tempo. So if at all we do get a new observation, the objective over here is to classify whether this song belongs to R&B song or is it a reggaeton song. Yes, this has been the sole objective as far as linear classification is concerned. Now, as of now, I've considered a binary classification model. We can go for even a multi-class classification model as well. Are you able to understand this image? Yes. So let's say machine learning is capable of generating this kind of a prediction. Means we can train the model maybe using a linear classifier, be it logistic, or we can even let's say implement non-linear classifiers as well, such as this is simply random forest. We can go for even boosting methods as well, right? Like XGBoost, DataBoost, Gradient Boost, and we can even go for let's say SVM night base as well. So this is just the case for linear classifier. Now, machine learning can also handle the case of non-linear classification. Yes, machine learning is also capable of handling non-linear classification. Can someone tell me which model can be utilized for the same? Which model can be utilized for non-linear classification? All right. Any other options other than KNN? Other than KNN, yes. Decision tree, definitely. Random forest, and let's say random forest, the evergreen model, or we can go for the XGBoost, right? SVM XGBoost. Definitely, they are capable of performing and generating better results when it comes to non-linear uh, data, right? So let's say machine learning models have been capable of working on both linear data and non-linear data. Clear? So the predictions we do end up getting is in form of a probability. Yes, and we need to predict whether the let's say data belongs to class 1 or class 2. Maybe class 1 is R&B song, class B is reggaeton song. The features being energy and tempo. I hope this is clear to everyone. Yes. Okay. Just a minute. Yeah. So now the question is why LLMs? Okay. So for machine learning, we have seen, right? So this is where this is the starting point where let's say we are training a model, and as of now, this is a machine learning model. So this is a very fundamental or a let's say a very rudimentary model, right? This is where let's say we need to scale it up to understand the concepts of deep learning. Now, what if data is not data is neither linear, data is neither non-linear? We have this kind of a data. We have vectors in form of let's say suppose we have text-based data, right? We have text-based data and we need to process this data to generate predictions whether the sentiment is positive or negative. And the text-based data is not present in form of text. Rather, we do have something known as word embeddings. Word embeddings are basically the vector representation of the data, right? So over here, we do have vector representation of data. And just in case we wish to apply, let's say, a machine learning model even for word embeddings, so we can proceed with the same as well. And for that, let's say it is capable of predicting whether it is positive or negative. All right. But suppose now, as far as the word embeddings are concerned, so the size is not quite small. When we are talking about word embeddings, the size can go into thousands and even beyond for each word. All right. Each word will be represented in form of a vector, and similar words would have similar vectors because vectors comprises of context. All right. So we do end up getting some semantic and syntactic clarity about the words in form of vector embeddings. All right. So essentially, when the size of the data grows, ML models would, let's say, fail to perform well, especially when we're talking about this kind of a data, or maybe when we have images. So machine learning models would not be able to, let's say, perform quite well compared to what we are, let's say, stepping up for. So next, after having, let's say, understood machine learning, next we have deep learning, right? So deep learning focuses on neural networks, which are the backbone of LLMs. So through deep learning, we can, let's say, gain a deep understanding of neural architectures like convolutional neural network, recurrent neural network, and let's say uh, the starting point for LLMs, which is the transformers. All right. So having some understanding of deep learning will help you better understand the concepts of convolutional neural networks and RNNs. And if you can, let's say, upskill yourself to the level of transformers, that would be great, because transformers are the starting point for LLMs. So transformers serve as the foundation for most modern LLMs. So suppose, let's say when the data grows large in size, especially these word embeddings, we have maybe lakhs and lakhs of, let's say, sentences for which we need to predict the sentiments for. And we may have, let's say, some sarcastic, let's say, text as well. And on top of it, we are generating a very large text embedding, word embedding. So this is where machine learning model might not be able to capture the, let's say, essence of the data that we are feeding into the model, right? So this is where, let's say, deep learning models comes into picture. So for, let's say, we can even work with image classification, text classification, and there are n number of couple of things that can be, let's say, implemented using deep learning. We can perform image segmentation, we can perform text clustering as well. So when we're talking about, let's say when the data no longer remains structured, right? When we have suppose image, we have audio, we have video, we need to implement some, let's say maybe sentiment analysis or image classifications. For these kind of applications, we need to have a neural network in the first place, right? This is the kind of structure that we may have for a neural network, and its architecture may vary depending upon the complexity of the data and the kind of task that we're dealing with. Guys, are you able to understand these concepts? Machine learning and deep learning stuff. Majority of you might be already familiar with these concepts, right? Okay. So let's say we are feeding in this image and we are training the model with n number of such images, maybe cats and dogs. So we may end up getting something like this. So this is a multi-class classification where we have three classes. We have cat, dog, and bird, right? So as you can see, these are the probabilities that we are getting. So this is how, let's say, neural network architectures are trained. This is how neural network architectures are trained. And if we wish to, let's say, predict the sentiment, then again, machine learning models, or rather, it's better to utilize deep learning models for such scenarios, right? Now, consider a deep learning model where, let's say, we are predicting the next word. Where we are predicting the next word, that is the example I'll be taking, let's say, to understand the LLMs and how after machine learning and deep learning, we are progressing towards the LLM. So LLMs, as discussed, let's say LLM training is the process of teaching LLM to understand and generate human language. This is achieved through feeding the model with massive amounts of text data or even text and image data in the case of multimodal architectures, and then utilizing algorithms to learn patterns and predict what comes next in a sentence. The resultant is an AI system that can generate human-like text, translate between languages, answer questions, and even perform many other cognitive tasks. All right, this has been the agenda so far. And this is what LLMs have been utilized to reach its fullest capacity. Now, just try to understand this. So you have seen this image, right? So over here, clearly we can see cat is in the box. Now, suppose we are training, let's say, an LLM, right? Which is an extremely large neural network to begin with. And on the surface, this is what we are considering. The cat likes to sleep in the. So we need to predict the next word, right? We need to predict the next word. So see, there can be n number of words that can follow after the. So don't you think this is a classification task? Out of n number of words, we need to predict the most suitable word. Is it a classification task? Yes. So to implement this classification task, we are utilizing an LLM. Means if it's just one word or maybe couple of words, maybe just one sentence, then of course we can utilize deep learning. But the fact is we are not, let's say, we are not utilizing LLM just to generate one word or maybe one or two sentences. We are utilizing LLMs for all these tasks. All right. Like translation, summarization, question answering, and even perform other cognitive tasks. So this is where we need to have LLM in the first place. This is beyond the capability of the generic deep learning models. The generic LSTM, BiLSTM, and even BERT, and maybe some advanced versions of BERT even can't handle these kinds of responsibilities. All right. Means they can be scaled, and when it comes to scaling up, that is why we have LLM in the first place. So after that, there can be n number of words, right? So this is where, let's say, LLMs come into picture. So just have a look. So we can create vast amounts of sequences for training a language model. This is where we need to, let's say, train the model with large amount of data, because we need to perform these kinds of tasks. So what are the tasks that we're dealing with? Translation, question answering, and let's say even, let's say, extracting a particular part of the text. Because when it comes to question answering, there can be any kind of questions, right? There can be any kind of questions as well. I hope this part is clear to everyone. Guys, just have a look. So over here, now it's not just, let's say, the next word that we are predicting, right? We do the same for much longer sequences. Are you getting this? We are doing the same for much longer sequences. And that is how, in a larger context, and the LLMs are trained. All right. So it's not just the next word. A trained language model can, let's say, the next word is generate, and after generate, the next word is coherent. Means, see, suppose when the next word has been predicted, so the next word is again, let's say, fed to the model for training, so as to generate the next word, the next to next word. A trained language model can, the next word prediction by the LLM is generate. And once the next word has been predicted, it is again fed to the model for training, because now the sentences a trained language model can generate, and then it is capable of predicting the next word, which is coherent. This is where the feedback comes from. Are you getting this? So guys, if you're familiar with, let's say, LSTM or how the RNNs work, yeah, recording will be shared as discussed. Recording will be shared. See over here what we are doing. First, let's say the model is predicting the first word, which is generate. Trained language model can, the next word is generate. Now, once the generate word has been predicted, it is no longer part of the input sequence, right? This has just been the prediction. So this prediction added along with the original input is fed to the model again. So as to allow the model to train and predict the next to next word, which can be coherent. Are you getting this? See, this is the sentence. This is the kind of sentence that we're dealing with. A trained language model can generate coherent responses or maybe coherent text. Is it clear? Is it clear, guys? So this part is referred to as the self-supervised learning. This part of the, let's say, LLMs is referred to as the self-supervised learning. All right. So guys, now I understand, means I'm hoping that you might be having an understanding about how, let's say, we have started from ML, then let's say we have catered to the subtle nuances of deep learning, and on top of it, let's say at the pinnacle of it, we have the LLMs. Yes, I hope this part is clear. So guys, now let's set up the, we are going to set up the API queue for the OpenAI and Gemini. All right, so do one thing. Just type this, open Google and type this, OpenAI API. Just type this. Done. Okay, just open the first link. Means, see, I'm not familiar whether your credit balance is zero or not. So first we'll check. And if it is zero, maybe you need to sign up with a different Gmail account. All right, open this link. Means I've already signed up, so you can click on sign up. Right over here, you can click on sign up. I've already signed up. Okay, just a minute. Yeah. So if you sign up, okay, let me just sign up over here. So guys, please complete the sign up and ping me once you have done. Once you are done. All right. So over here, go to your profile. Go to your profile. Go to your profile. Done. So in your profile section, you can come to the API keys. Means you can go to the pricing page. I'll show you. Now there's an option for billing, right? There is an option for billing. The my credit balance is showing 0. So there might be need to recharge it. So check. Go to this page. Means you need to go to your profile, right? First of all, you come to your profile. Then in your profile, just directly come to the billing part. What is the number that you see over here? Is it 0? Okay. Just have a look. On Google, just type OpenAI pricing. Type OpenAI pricing. All right, just sign up over here. Yeah, take your time. So once you sign up, let me know. If you have signed up over here, let me know. See, sign up page it would be different. You need to log in. You just need to sign up. Just click on OpenAI API pricing. Click on the first link. Click on the first link and sign up. Over here, you find an option for sign up, right? You have to sign up using your Gmail account. All right. So once you sign up, uh, are you able to? Is everyone on this page? Do I see this page? What about the remaining students? Guys, are you able to see this page? Please respond. All right. So assuming everyone, let's say, has come, means everyone has arrived on this page. Let's go to your profile. You can search to your profile and go to the billing section. Go to the billing section. Now just check the balance over here. Check the balance over here. What is your balance? What about the remaining students? Guys, what is your balance? 0. Everyone is getting 0. Okay, so you just need to log out from your Gmail account. Create a new Gmail account. Billing section. This is the billing section, right? Click on your profile. You have to click on your profile and then you can come to the billing section. Then you can come to the billing section. 0, right? So means you need to sign out from your Gmail account. Log in with a different or unused Gmail account. Let's say that you have rarely used. Use a Gmail account with which you have never used ChatGPT before. And if you're not able to recall, create a new Gmail account. Let's check this. See, till the previous master session, this was the case. Okay, so this service it seems has stopped. Previously, this service was available. Just check. Sign up using a new Gmail account. Over here it says OpenAI no longer gives free credits to new account. Free trial tokens to API users on platform are only given first time when you sign up. Okay. Sign up with a new account. All right. All right. So let's validate whether we are in a position to, let's say, utilize this or not. Let's validate this. Now to validate this, what we can do means everyone is on this page, right? Everyone is on this page. All right. Do one thing. Just a minute. Guys, just a minute. I need to log in with a different account, right? Just give me a minute. I'm sharing the screen. I'm stopping the screen share for a minute. Just a minute. All right, guys, just have a look. So let's experiment this and check whether we are able to create the API or not. Means let's just check. Go to your profile. Go to user API keys. Go to user API keys. All right. Now over here, do you find this option of create new secret key? You find this option of create new secret key. The remaining students, can I get a response? Go to your profile, then you'll find this option of create API keys. So what you need to do, all right, you need to create a new secret key. You need to create a new secret key. Just copy it. You can simply copy it. All right. So over here, just to check whether it is working or not, we're simply going to check, let's say, whether this functionality is working or not. All right. So for that, over here, I'm writing. Okay, you need to import it as well. Let's do one thing. Open your Google Colab. Guys, open Google Colab. Connect to GPU. Open Google Colab and connect to GPU. See, don't close this window. See, when you create a new API key, right? Don't close the window. Means I do have this API key as well. So I think I've overconsumed it. Let's see. Okay, I'm calling this key as key 31st August. All right. So create the secret key. Now don't close this window before copying this. All right. So copy this. I've copied it. So this is my Excel. Are you guys following along? Are you guys following along? Okay. So over here, I've copied the API key, right? So this is my OpenAI API key. Means you might be having a different API key. So we are just validating whether it's working or not, all right? We're simply going to validate whether it's working or not. So over here, there are a couple of dependencies that I need to install. So just install OpenAI and LangChain. Install them. Connect to GPU, go to edit, notebook settings, and then T4 GPU. Means over here, I'm simply going to check whether I'm in a position to, let's say, utilize this. I'm simply checking whether we are in a position to utilize this version or not. Means we need to make the payment or not. All right. Is it clear? Guys, please respond. All right. So have you installed this? Proceed with the installation. You have to install these libraries, right? Okay, I'm sharing them in the chat. Okay, so I'll show you. So over here, as you can see, I've installed LangChain and OpenAI. Then, okay, you have to install this as well. Let's keep it simple. Get this installed as well. Put install LangChain OpenAI. Copy your own API key. Copy your API key. And install LangChain OpenAI as well. API key is over here. All right, over here we will find the API key. These are the three dependencies that you need to install as of now. All right. These are the three dependencies that you need to install. Copy, see there's a clearly there over here, there's a button to copy, right? You click on create new secret key and then type the name and you'll get a button to copy it. Yes. These are the dependencies. I'm sharing it in the chat. Since I've already copied it, this is my API key, right? Once you've copied it, you can close it. Next, over here, we are just validating whether we can utilize it or not. Guys, is this part of the code? Have you executed this part of the code? All right. So next, and you have set up the API key as well, right? So over here, I'm directly passing the API key. So I can set it up as a can set it as an environment variable. That is not what I'm doing over here. I'm setting up directly over here. So we have defined this already, right? We have defined this already. This is OpenAI API key. See, I cannot share the API key. Rest everything I can share. This part I've already shared. Okay. Yes, this part I can share. This is the code you need to execute. And then over here, I'm just checking whether, let's say, it works or not. So over here, we are simply converting, we are translating English to French, all right? Or maybe English to Hindi. Right. Suppose this is the sentence. This is the sentence I wish to translate. Let me run this and then we'll see. Okay. So as of now, it's working. It's clearly able to translate, right? So if you have executed this part, the API key is working in my case. If you can check whether it's working in your case or not. Means this was just to check whether our API key is working or not. All right. How to enter the API key? See, once you have copied it from here, you just need to paste it, right? Once you have copied it from here, you just need to paste it. Have you fetched the API key? Have you fetched the API key? All right, just paste it. See, over here I've created a variable. The variable is OpenAI API key. Paste your API key over here. All right, OpenAI API key. And then this is the code we have executed. So I've created let's say chat OpenAI instance, and which I've called it as LLM. The model that I'm utilizing is GPT-4o. Let's say there are a couple of other parameters for certain randomization. And this is the message. Let's say this is the sentence I wish to translate. So clearly, as of now, it's working. So if it's working, it means, let's say, SK is not defined. Where is SK? SK I have nowhere used. Okay, maybe if this is not the case, then you can utilize model is equal to GPT, then 3.5. Try utilizing this. If 4.0 doesn't work, try utilizing GPT 3.5 turbo. GPT 3.5 turbo. Okay, this code, yes, sure. See, do one thing. As of now, just go through the code, right? See, because the pace at which I'll be implementing might not be the same as your pace. So it's better that as of now, you just, instead of, let's say, coding along with me, instead just focus on the code and just try to understand what is being explained, right? Means you need to create any variable. Over here, I've created a variable such as OpenAI API key. Right? If GPT 4.4 is not supported, try utilizing GPT 3.5 Turbo. Means this is just a validation code just to check. See, I told you first you have to install this. First you have to install this. I've shared this code in the chat. I've shared this code in the chat. First you need to install OpenAI LangChain and LangChain OpenAI. So you need to use Colab. Are you using Colab? Okay, I'm sharing it again. So there might be some dependency issue. I'm sharing it again. Please install it. Guys, instead of code along, if you guys can just focus on the code and try to understand what is being explained, that would be better. Otherwise, it might consume a lot of time. Just validate whether this API key is working or not. That's it. Is it working? Is there anyone all right? What about the remaining students? Guys, is it working? I've shared the remaining code. Everything has been shared. You'll have to scroll through the chart. Okay, quota exceeded. So try logging in using another account. Try logging in using another account. So as of now, clearly you have seen how to create an API key. Yes. Now you have seen how to create an API key. Now, in case for those of you who are getting the error, previous start is there, no one is deleting it. You'll have to scroll up. See, you have to write it in double quotes. How have I written it? How can you API key just do 2 words? It's an entire string, right? It's a very long encrypted string. You'll have to copy the entire string, and it has to be in quotes. It is a string. It is a string variable. To use GPT 3.5, you have to write this. You have to write GPT hyphen 3.5 hyphen turbo. Sudeep, you have mentioned the API key incorrectly. All right, so either you can do the payment if needed. Otherwise, you can just, let's say, follow along. Means if you're not interested in payment, no issues. Maybe just follow along. You'll have a better understanding how we are implementing this. Maybe you can create a new Gmail account and then sign up into OpenAI using that Gmail account. For new Gmail account, at least I think one OpenAI API key you might be able to use for free. Is this done? Now, for those of you who have been able to successfully, let's say, implemented this, did you guys sign up with a new Gmail account? Did you guys sign up with a new Gmail account? Tarushri and Shubham, Suvitha, did you guys sign up with a new Gmail account? So guys, everyone please sign up with a new Gmail account. Only then you might be able to, let's say, implement this. Sign up with a new Gmail account. An account with which you have not utilized ChatGPT before, or maybe create a new account. All right. What is the error? Yes, rate limit error means you need to use a different Gmail account. Rate limit error means you need to use a different Gmail account. You can't utilize using the same, or you have to make the payment. The choice is yours. All right. So this was just an example to set up, let's say, LangChain and OpenAI. And as of now, for my system, let's say the API key is working, right? The API key is working. Alternatively, there's another option that we can explore. See what we can do. There's another option that we can proceed with. All right, let's say you can set up Google Gemini key, right? If you are not, let's say for those of you who are not able to set up OpenAPI key, you can set up Google Gemini key. Now to access Google Gemini key, what we need to do? See over here, we are passing Google API key, right? Over here, we are entering the Google API key. Now where to fetch this Google API key from? Guys, let's understand where to fetch this Google API key from. So go to Google, go to Google and type Gemini API key. Go to Google and type Gemini API key. Of course, you need to sign up over here. So see, just check. Is there an API key pre-existing? Just check this. Please check, is there an API key pre-existing? Okay. Click on create API key. Click on create API key. Just maybe type something, maybe first project or something. Create API key in existing project. So over here, let's say it is creating a new API key, right? You can simply copy it. You can simply copy it. Guys, are you able to create the Google Gemini API key? Are you able to create the Gemini API key? Yes. All right. Now copy this API key. All right. I'll show you. this is when let me close these files. Now, over here, this is my text Google API key, right? Well, this is my API key. I've copied it over here, and then you need to install this. You need to install this. I'm sharing you this code. See, previously, we have installed LangChain OpenAI, right? So LangChain OpenAI was, let's say, utilized to establish connection between OpenAI API key and the LangChain. And likewise, we have LangChain Google API, LangChain Google Gemini, that is used to establish connection between LangChain and the Gemini API key. All right, so please proceed with this installation. Hopefully, here you won't end up getting the, let's say, the rate limit exceed error. Now, this is a different function that we're inputting. All right, so over here I'm utilizing Gemini and API. So we will need to set up the environment or will it work? Let's see other params. Okay, I'll have to check the other params. Chat Google generated AI. Okay. API key I'm passing this a bit. Means let me just implement this and then I'll share this code in the chat. All right, so as of now it's working. And then let's copy this. So I'll call this LLM2, all right? This is LLM2. Now this is some text message. This is LLM2 dot input message, AI message 2, and let's say, okay, let's translate this. Okay, this is my sentence. I wish to translate this sentence to French. Okay, learning LangChain and LLMs after machine learning. Let's run this. So we are translating it into French. All right, as you can see, even this is working. So let's say those of you who are facing problems or who are facing rate limit issue, or maybe you need to create new account. So you can skip that part. You can use Google Gemini key, right? I've shown you how to create the Google Gemini key. This was the, let's say, OpenAI key, and this is the Gemini key. Have you created this? All right. Yes, sure. I'll share the code. This was the first part. Then this is the next part. I'm sharing the code. So over here you won't find rate limit error. All right. Over here you won't find rate limit error. Yeah. This is the code I've implemented. Please check and validate. Done. Guys, is this done? Please respond. I've defined it over here, right? This is LLM2. Over here, I've defined it as LLM2. Please avoid spelling mistakes. So means if you're using Gemini API key, you don't need to use. You don't need to, let's say, you can ignore the rate limit error issue, right? So instead of proceeding with OpenAI, you can proceed with Gemini API key. All right. So it means this is just the first step. Over here, we are just setting up API key, and we are validating whether it's working or not. All right. We are validating whether it's working or not. So for ChatGPT, yes, you can try it in Jupyter Notebook as well, but you'll have to install the dependencies. You'll have to install the dependencies. You can try it in Jupyter as well. So guys, I hope this part is clear to everyone. How to generate and set up API key for OpenAI Gemini. See, it says you do not have access to it, right? So you need to make the payment. You need to make the payment, or what you can do, you can utilize GPT 3.5. You can utilize GPT 3.5, all right? Utilize this. Instead of writing GPT 4.0, just change it to this. Seriously, you can change it. I've shared the code in the chat. Remove GPT 4.40 and utilize this. Is it clear? Is this part clear to everyone? All right. So guys, next we are proceeding with, let's understand the role of vector databases, right? Let's understand the role of vector database. So around for 15 more minutes, we'll have the theory part, around 15 to 20 minutes. Then we'll proceed with the practical implementation. All right, now to understand this concept of vector database, we have just seen one practical implementation, which is the word embeddings, right? See, any machine learning or deep learning model and even any LLM cannot accept string as input because of all the mathematical calculations involved. We cannot, let's say any model cannot accept string as input, right? So we need to convert strings into embeddings. And embeddings are essentially comprised of vectors. So this is where vectors come into picture. Are you getting this? When we are talking about vectors, word embedding, and vector database, let's understand this concept. Vector is essentially a list of numbers that represents data points in space. This is the, let's say this is a very fundamental definition of vector, but this is sufficient enough to understand or let's say uh, comprehend the role of vectors in embeddings, right? So for any string, for any text-based data that is not directly fed to any machine learning model, rather what we do, we convert the text into embeddings or vectors. Now in NLP, a word embedding is a vector that represents a word's meaning based on its context and usage in the large corpus of text. So if you guys are familiar with the LSTMs, and again, see, I will. Okay, Tarushi, can you that just skip the part? Maybe you can log in with a different email account. You can log in with a different email account. All right. Just log in with a different Gmail account and use OpenAI API key. So over here, we are discussing about the word embeddings on the vector database. So in NLP, word embedding is simply a vector that represents a word's meaning based on its context and uses in the large corpus of text. So in context of LLMs, whenever let's say we are training a model to let's say to apply it in a chatbot where maybe we are generating a chatbot, a conversational chatbot based on a PDF or maybe multiple PDFs, maybe based on uh, let's say some other corpus of text. So over there, what can be done? We need to store this large corpus of text, right? We need to store this large corpus of text in form of embeddings. All right, and this storage unit is referred to as the vector database. So in context of LLMs and natural language processing, these vectors typically represent the words, sentences, and even entire documents in form of embeddings. Are you getting the significance of the vector database or vectors in general? Suppose means maybe in another half an hour, we'll be creating a chatbot where we are training the chatbot based on certain PDF, right? So what is the objective over here? What is the objective of vector database? We need to store the content of the PDF in form of, the content will be available in form of words, right? We'll be converting the words into vectors and then we'll be storing the vectors into vector database. Are you getting this? So the words or the sentences present in the PDF will be stored as vectors in form of word embeddings into the vector database. So vector database is a specialized type of database designed to store, index, and retrieve high-dimensional vectors, which are mathematical representations of data points in continuous vector space. Guys, is the role of vector database clear to everyone? Is the role of vector database clear to everyone? Remaining students, can I get a response? See, it's not just about passing a sentence or multiple sentences. We are passing an entire PDF or maybe multiple PDF, an entire book. A PDF can be a book as well, right? So that is the amount of volume of data that will be feeding into the model. So we need to have a large corpus of word embeddings as well, and we need a storage unit. This is where vector database comes into picture. Now, there can be different types of vector database, which we do have multiple options. We have DB, we have Pinecone, we have FIS. As of now, as far as this masterclass is concerned, we'll be using FIS because that is conveniently easy to use compared to Pinecone, because there we need to set up the account. All right. So vectors used in NLP, vectors are often used in NLP tasks, and they have hundreds or even thousands of dimensions. So as and when vectors grow into dimension, this is where, let's say, machine learning models would fail to scale. This is where the machine learning models would fail to scale up to that extent. And this is where, let's say, deep learning models come into picture. And when we are using, let's say, deep learning models for with word embeddings, now when the data size increases in size, so this is where LLMs has to come into picture. Are you getting this? With larger size of embeddings, first we step from machine learning to deep learning. With larger size of data, we are moving from deep learning to the LLMs. All right, so vector databases are optimized to handle these high dimensional vectors, supporting operations like nearest neighbor search, similarity search, and clustering. So all the vector database, they do support, let's say, similarity search. And this similarity search is based on context, semantic search, contextual search, syntactic search as well. We can also apply clustering as well. And let's say it also supports nearest neighbor search. So all the functionalities coupled with certain enhanced functionalities of LLMs, means all the, let's say, the previous functionalities that we are familiar with when it comes to machine learning, we are familiar with what is nearest neighbor, right? You guys have gone through the nearest neighbor algorithm. We are familiar with the concepts of clustering. So for those of you who have worked with, let's say, cosine similarity, you might be slightly familiar with similarity search or cosine similarity. If you have worked with text clustering data over the recommendation system, so you might be slightly familiar with similarity search or maybe cosine similarity, right? So likewise, we have a much advanced level of similarity when it comes to vector databases. Over here, similarity is in terms of semantic, syntactic, contextual similarity. All right, so means after having, let's say, stored the embeddings in the vector database, we can apply functionalities related to similarity search. We can apply functionality related to clustering as well. Guys, is this clear to everyone? What is the role of vector database? Is it clear to everyone? Please respond. All right. Essentially, we'll be utilizing vector database to store the PDF data in form of word embeddings, right? First, we'll be reading a PDF. We'll be converting the PDF into chunks. All right, means we need to split the data into, let's say, character into different characters. Then we need to store it in form of chunks. We'll be converting these chunks into embeddings, and then we'll be storing these embeddings into the vector database. Is this procedure clear? All right. Now, what is the role of vector database and LLM-based chatbots? So let's say the first and foremost, one of the most significant role for vector database that we have is efficient retrieval of relevant information. So vector database enables the chatbot to efficiently retrieve the most relevant information by comparing users' query. See, over here we do have a functionality for similarity search, right? So suppose we are searching for something. We write a query, we write a prompt, and based on that prompt, it will apply the similarity search between the user's prompt and the vector embeddings. All right, and the word embeddings that is stored into the vector database. So vector database enables the chatbot to efficiently retrieve the most relevant information by comparing the user's query vector with pre-stored vectors of potential answers or documents. All right, so they enable the semantic search where queries and stored data are compared based on the meaning, not just exact word matches. Are you getting this? Guys, are you getting this? All right. Next, let's say vector database also supports handling large scale data. So vector database are designed to scale efficiently, allowing chatbots to manage and search through millions or even billions of vectors in real time. All right. So the amount of data, let's say that we are handling over here, they can be of different data types. All right. And vector database also facilitates high speed, let's say similarity search. They facilitate high speed similarity search. All right. And instant responses when it comes to chatbots. Now we can also add a touch of personalization and contextual awareness. So let's say as far as personalization and contextual awareness is concerned, there are two key points that I would like to discuss: user profile and preferences. So chatbots can, let's say, they can store user profiles, they can store user preferences, and even the past data. Suppose you have interacted with ChatGPT maybe 3 times based on a particular context. So is it keeping track of the context as well? Yes or no? Is ChatGPT keeping track of the context as well? Yes. You ask file related question, maybe 2 to 3 questions, and then ask another question maybe based on the first question. Is it able to track the context? So likewise, vector database, let's say when we are utilizing in chatbots, they can store user interaction preferences and history as vectors in form of vector database. So by comparing the current interaction vector with the stored vectors, the chatbot can generate maybe personalized responses based on previous interactions, right? Making the conversation more engaging. And it also keeps track of the context. All right. Besides storing the user profiles and preferences, it keeps track of the context. All right. And thus it is able to retrieve contextually appropriate responses from the data stored in the vector database. Because we need to track of the conversation flow as well, right? Conversation flow needs to be tracked as well. That is why, let's say, we do utilize some vector database. All right, and it supports complex query types. So vector database is not only meant, let's say, for PDF. Vector database is not just meant for PDF. It can support a variety of data types or in general, the multimodal architecture. So we can generate embeddings for different types of data, such as text, images, or even structured data like tables. These are some common examples. It can be scaled up for more complex data types as well. Is it clear? And there's another key point. Let's say I might have missed in the P2P. Vector database do support chain queries, right? They support chain queries and reasoning. Chain queries means, let's say, in machine learning, are you guys familiar with, let's say, chaining? Are you guys familiar with chaining in machine learning or even in pandas? So have you created pipelines? Are you guys familiar with the concept of pipelines? In pipelines, we are chaining, let's say, a particular n number of particular steps in a sequence, right? One after the another. Yes, that is referred to as chaining. We do have the concept of, let's say, chaining in pandas as well. All right. So vector database, they do support chain queries and reasoning as well. All right. We can chain multiple queries together so that, let's say, the response of one query can be fed as another query. Means the output generated maybe by chat GPT. Suppose I wish to utilize the output as in form of another prompt. So that is when chaining comes into picture. Is it clear to everyone? All right. Guys, next, so we need to understand, we are going to understand a quite high level concept, which is referred to as RAG. All right. We are going to understand the concept of RAG. And again, before starting the RAG itself, so let's say we are discussing it on a surface level. We are going to discuss RAG on a surface level, right? All right. So let's understand this. So these days, let's say whenever you come across a chatbot, it is coupled with RAG. The chances are high that it is coupled with RAG, it is integrated with RAG, it is optimized to cater a particular or to handle a particular problem statement, right? So let's understand what is RAG. RAG stands for Retrieval Augmented Generation. RAG is Retrieval Augmented Generation, and as the name sounds, it is, let's say, comprised of three fundamental actions or three fundamental tasks in the first place. So we have this retrieval phase, then we have the augmentation phase, and then in the end, we have the generation phase. So RAG is a framework that enhances the performance of a large language model by integrating retrieval-based methods with generative capabilities. All right. So let's say this is the part where we are further optimizing the capabilities or enhancing the functionalities of LLMs to make it more robust and accurate. Are you getting the picture? We are trying to enhance the performance of LLM. Means RAG is completely different from the fine tuning part, right? That is an entirely different concept. And over here, we are optimizing the performance of the output that an LLM can potentially generate by utilizing the concept of RAG. So we are trying to integrate the retrieval-based methods with generative capabilities. So over here, the sole objective is to minimize the hallucinations. We have all witnessed and seen ChatGPT at times tends to falter, tends to hallucinate. Yes or no? ChatGPT tends to falter and hallucinate, right? Not every time, but let's say a couple of times. We have all experienced the same. So let's say when a chatbot is coupled with RAG, right? So this approach helps LLM provide more accurate and context-aware and relevant responses, especially when dealing with complex queries that require specific or up-to-date information. The objective over here is to prevent the, let's say, LLM from guesswork. We are restricting the LLM model to proceed with guesswork. We are not allowing the LLM model to make a guesswork for any query or some queries in general. Is the objective clear why we are utilizing RAG? So it acts as a bridge combining the creative responses generation of the models with the precision of retrieval-based methods. All right, so we'll be utilizing the precision of retrieval-based methods, ensuring that chatbots can source and integrate external information with far more accurate responses. All right. Is the concept clear for RAG? As in, to some extent, are you able to understand why we are using RAGs in the first place? Guys, can you please respond? What about others? The sole objective over here is to minimize the hallucinations. I'm not saying stop the hallucinations. All right. I'm not saying completely eliminate the hallucinations, but definitely minimize the hallucinations which we might face. That is where RAG comes into picture, right? So let's understand the let's say difference between a chatbot with RAG and a chatbot without RAG. So chatbots without RAG are limited to responding based on their pre-existing knowledge, which can lead to incorrect or hallucinated answers when faced with an unfamiliar question. That is what I've explained, right? See, there are three steps. First of all, it is going to retrieve the relevant information from the vector database. Then it is going to augment it with the element, let's say LLM responses, and then it is going to generate the corresponding responses. So these are the three steps. So this retrieval part is based out of the vector database. Means it can be based out of the vector database. Retrieval means extraction. So this extraction is done utilizing the vector database. It's one of the approaches utilizing the vector database, right? Chatbots without RAG are limited to just responding based on their pre-existing knowledge, which can lead to incorrect or hallucinated answers when faced with unfamiliar questions. This means they might guess the answer, often resulting in hallucinated responses. And I'm hoping we have all seen ChatGPT falter at times. Yes or no? Guys, we have all witnessed ChatGPT falter, right? All right. Now, ChatGPT chatbots, let's say enhanced with RAG, can access and use external information to answer the questions. All right. This capability allows them to provide more accurate and reliable responses, even for questions outside their initial training data. Are you able to grasp this concept? It means essentially we are trying to limit the guesswork when it comes to ChatGPT, right? You can ask any kind of questions. Yes, mostly any kind of questions are allowed, except maybe for certain, let's say, uh, genuinely prohibited questions. Otherwise, majority of the questions from any particular domain, as far as it is, let's say, positive questions, you can definitely ask in under a certain umbrella. Are you guys getting it? But at times, let's say, as you increase the complexity of the questions, there might be a situation where you may end up facing some guesswork type of answers, right? That is what we are trying to prevent when it comes to RAG. Now, the documentation itself means where else do you want to utilize it? It can be utilized at means there's a research paper, there's an entire research paper on the same. It can be utilized elsewhere as well, depending on the requirements. All right, now let's understand the three essential components of RAG. So we have this retrieval system. In RAG, we have the retrieval system, then we have the augmentation part, and this is the generation part. Sorry for the typo. So as far as the retrieval is concerned, this component searches large corpus of documents or a knowledge base to find the most relevant pieces of information based on the user's query. This is the retrieval part, right? So this retrieval method comes essentially out of the vector database, means we can set this up to the retrieval part. Now, the retrieval step usually employs methods like dense passage retrieval. All right, we have a concept called dense passage retrieval. You can go through the documentation. You can means in the documentation you won't find it. You'll find it in the, let's say, the paper, the research paper. In the research paper for RAG, you'll find this dense passage retrieval, or means we do have some other vector-based search algorithms that transform both the query and the documents into dense vectors and then find the nearest matches. So previously we have discussed about the similarity search. Right? That is facilitated by, let's say, the vector databases. So even RAG is further optimizing the same. Right? Next part is the augmentation. So the retrieved documents or snippets are then passed to the generative models, all right, as additional context or knowledge. Are you getting this? That first part is the retrieval, second part is the augmentation. Augmentation is basically modifying modification of the existing answer, modification of the output generated by, let's say, the LLM models, right? And the third part is the generation. Ignore the typo. So the generated models such as LLM uses both the original user query and the retrieved context to produce a coherent and contextually accurate responses. Now, this component leverages the language model's ability to generate natural language text enhanced by specific information retrieved earlier. So whatever was retrieved earlier has been enhanced by RAG. Are you getting this concept? It's on the surface level, is it clear? All right. Before starting RAG itself, I mentioned, means I clearly stated that we'll be discussing RAG on a surface level. Means if you go through the research paper, there are n number of intricacies involved. There are n number of complexities that, let's say, that can further extend the conversation beyond, as of now, which is beyond the scope of this session. So there are n number of other things that we can, let's say, work upon and discuss when it comes to RAG. So essentially, we have discussed that there are three parts: retrieval, augmentation, and generation. Next, what are the advantages of RAG? So definitely, we do end up getting enhanced context awareness. Yes. Guys, is it clear? Over here, we do get some enhanced context awareness. Then we also have improved accuracy, and we have dynamic knowledge integration, right? All right. Now let's understand this. Why learn chatbot building in 2024? So learning to build chatbots in 2024 offers numerous advantages due to increasing integration of AI-driven conversational systems across various industries. These days, every other, let's say, tech giant is into, let's say, conversational systems. Whether it is for clients, whether it is for users, whether it is for stakeholders, whether it is for some internal projects, everyone is dealing with these days. The tech giants are dealing with conversational systems. All right. So to explore why, let's say, of course, we have a widespread adoption and demand for the chatbots following AI-driven conversational systems. All right. Now, because of the advances in the AI and the NLP technologies, we need to, let's say, upgrade ourselves as well for future-proofing the careers to stay, let's say, adept with the AI technologies that we have at hand and the upcoming technologies. First of all, we need to understand LLMs and chatbot and how to, let's say, work with them. All right. So we can integrate them with the other technologies as well. We can integrate these, let's say, chatbots with other technologies as well, as in we can integrate them with IoT devices as well. We can integrate them with kiosk as well. All right. And if you have recently explored, let's say, carriers based on ML and DL, so majority of you might have come across chatbots and LLMs. These days, if you open, let's say, any let's say, websites such as maybe Indeed, maybe Glassdoor, maybe Naukri.com, so you might have come across the terms chatbots, LLMs, LangChain, Llama Index. Yes. Have you explored opportunities in this domain? Or any ML or DL related opportunity have you explored during the past, maybe past 1 year? Past, let's say, 3 to 4 months, guys, have you explored opportunities in this domain? Please respond. Yes or no? If you have let's say, explored career opportunities outside of data analysis, let's say if you look forward to, let's say, join any organization as an ML engineer or maybe AI engineer, all right, or maybe some junior data scientist or these kind of profiles, definitely LangChain, chatbot, Llama Index. These are the key priorities. These are the key priorities that one needs to get themselves familiar with. All right. Now, let's say we can automate as well when it comes to chatbots. Means we can integrate with some other technologies and couple of tasks can be automated as far as conversations are concerned. All right. We can keep track of a number of conversations, and let's say a couple of things can be integrated and automated as well. So definitely it enhances the productivity. And of course, we need to understand chatbots and LLMs for future proofing careers. Guys, I hope is this clear? Why we should learn chatbot building in 2024? If you explore any career opportunity related to machine learning and deep learning, especially let's say if it's a non-data analysis profile or even data analysis profile. So if you want to scale it further, you need to, if you're looking forward for a sustainable career option, definitely LangChain, LLMs, chatbots is a must-go option for. All right, guys, next we are directly proceeding with the chatbot building. All right, we are proceeding with the chatbot building. So please open up VS Code. Means if you're following along, maybe you can open VS Code. Okay, I've copied the API key, right? Over here, what I'm going to do. First of all, I'm going to create a virtual environment, all right? First of all, I'm going to create a virtual environment. So I'm assuming everyone has VS Code installed or at least can set up VS Code on their own. Yes, you guys have VS Code installed, right? You guys have VS Code installed. Please respond. All right. So over here, I'm going to first of all, I'm going to create a virtual environment. Over here, I'm going to create a virtual environment. So, guys, as you can see, this virtual environment is created. Now we'll be creating a folder. We are going to create a folder. First of all, we'll be activating the virtual environment. We'll be installing the dependencies. All right. I do have these dependencies installed. Otherwise, as well, it will work even without virtual environment when it comes to, let's say, the configuration that I have. All right, but let's install. Okay. So first of all, over here, I'm creating. Right, I'm calling it LLM chatbot. I've created a folder called LLM chatbot. Now I'm going to activate the virtual environment, right? So guys, as you can see, this is how we can activate the virtual environment. As far as this virtual environment is concerned, over here there's a scripts folder. Inside the scripts folder, we need to activate this activate.bat file. We need to activate this BAT file. Is it clear? So clearly you can see we are inside the virtual environment. Now I've created this LLM chatbot, right? Let's go to this folder. Right now I'm inside this folder. Now over here I'm creating, let's say, PDF chart.py. I'm creating a file called PDF chart.py, and I'm also creating another file which is requirements.txt. Right, guys, over here I'm creating a file called requirements.txt. This is where we are going to install all the dependencies. All right, this is where we'll be installing all the needful dependencies. Is it clear? Means are you guys moving along, or are you guys just following? Can I get a response? Guys, please be responsive. Means I'm asking, are you guys coding along with me, or are you just are you guys following along with the session? See, what are the dependencies required? First of all, I need streamlit, right? First of all, I need streamlit. Then I need langchain. All right, because we'll be working with SQL as well. All right, I need PyPDF tool. So this is required to read data from the PDF. Then I need FIS, which is Facebook AI similarity search. This is the vector store. And I'm importing a couple of libraries. LangChain experimental, then LangChain community. Okay, LangChain OpenAI, LangChain Core. Then I might need PyMySQL. I'm installing the dependencies for all right. Okay. PyMySQL. Then I might be needing MySQL connector. All right, MySQL connector Python, and then let's see. All right, that should be enough. All right. Yeah, you can mention the versions as well. If required, you can mention the versions as well. At times, see, that is the sole reason we are in the virtual environment, right? So that there is no dependency conflict from any pre-installed library that I might be having. That is why I'm creating virtual environment in the first place, and I'll be installing all these dependencies. Clearly, you can see the virtual environment is activated. So I'll be installing all these dependencies once I write this down. So over here, I have Streamlit, then LangChain, PyPDF2, files, then LangChain experimental, LangChain community, LangChain, okay, see, this is spelling mistake, LangChain OpenAI, then LangChain core, PyMySQL, MySQL connector, Python. All right, and all right, that should be it. LangChain is there, yes. So clearly, as you can see, we are over here, and this is where I do have the requirements. So click install requirements.txt. Just a minute. Just a minute, guys. Am I missing any requirement? Okay, I didn't know. I haven't saved it. I haven't saved it. Requirements.txt. We are in the master class 31st August, right? This is the folder, and I'm outside this folder, right? Requirements.txt. Seems correct. Let's see. Yeah, see, it is getting installed. Let's wait. Meanwhile, and this is where we'll be creating the chat with PDF app, right? So meanwhile, let me write the dependencies that I need over here. All right. So over here, let's say this will be the application, but over here, creating another file, which is let's call it. I'm storing the vectors over here, right? I'm storing the vectors over here. So I'm calling it vector.py. Let's wait for the time being while it is getting installed. Over here, I need to write from LangChain community. I need to include means I can use the PyPDF too as well. Then from langchain.textletter, from langchain.textletter, I'm importing recursive character text letter. All right, we'll check for the spellings and from LangChain community. Vector source. Over here, I'm importing twice. All right. And from LangChain OpenAI, over here, I'm importing OpenAI embeddings. All right. So guys, over here, I'm creating, let's say, a PySpark, right? I'm creating a folder where, let's say, the document will be stored in form of the embeddings. Are you getting this? Let's call it vector store, and then DB files. This is where, let's say, the vector embeddings will be stored. All right, now I need to load a PDF. All right, so as you can see, the dependencies are installed, right? Now, over here, I do have these files. I do have these, let's say, PDFs, right? I do have this astrology PDF, then budget PDF. So as of now, let's say I'm utilizing. Now, let me add, let me move these files to this folder. These are the PDFs, means these are the PDF that we can work upon, all right? So over here, I'm writing a loader, and loader is going to be PyPDF. PyPDF loader, over here, I'm, let's say, going for India budget, all right? This is India budget 2024.pdf. All right, and then as far as the docs are concerned, over here, I'll be passing loader.load. Then I'll use the text splitter. So that the text splitter that I'm going to use over here is the recursive character text splitter. All right, and I'm passing the chunk size. Chunk size is 1000 and chunk overlap. That means let me write the code and then I'll explain it as well. The chunk overlap that I'm considering is 200. Then splits. Over here, I'm setting up the splits. Text splitter dot split documents. because it is an object of recursive character splitter, that is why I'm in a position to apply the splitter, apply the split documents functionality over here. All right. So this is a document where it is loaded in form of the PDF file. This is the object of text splitter, and using the text splitter, I'm splitting the document into a chunk size of 1000 with a chunk overlap of 200. Means the 200 characters from the previous document will have an overlapping with the next 200, let's say, characters of the next document. All right. So that there is some contextual, let's say, similarity available. Are you getting this? Then over here, I'm setting up the vector store. All right, and this vector store is going to be files dot from documents. So what is the document that I wish to pass? Over here, the documents is going to be splits. All right. And embedding over here, I need to set up the embedding. So let me set up the embeddings over here. Let's say I'm calling it LLM. And in LLM, I'm passing this OpenAI embedding. All right, now I need to check the API key, right? What was my API key? The API key I copied over here. Yes, this is my API key. So guys, this is my API key. All right, this is the API key that I'm using. And in OpenAI embeddings, over here, I need to set the API key. So this is just the first step. This is just the first step. All right. Okay, I'll explain this one. So there are a couple of other things. Then we need to apply vector store dot save local. All right, and I'm storing it over in this file. This is where I'm storing it. All right. So just have a look. So see over here, first I've set up the API key. I've created an instance of OpenAI embeddings by setting up this OpenAI API key. I've created a path, db5 path that will, let's say, which will be used to store the vector embeddings. Then I'm reading this PDF file using PyPDF loader, and then I'm using the load function to load the file, and then using a recursive character splitter into a chunk size of 1000 with a chunk overlap of 200. I'm splitting this data into docs, into different docs, right? And from this doc, I'm creating the embeddings, and FICE is converting these documents into embeddings. All right, and it is saving it into this file, db5 path. Is this clear to everyone? Guys, is it clear to everyone what we are doing over here? So this vector, okay. So let's run this. Over here, I'm going to LLM chatbot. I hope there's no spelling mistake. All right, let's run this. So see, I've predefined the, let's say, PDF which I'm using. We can also create maybe browse option in the front end using Streamlit to upload a PDF file as well, right? So over here, I'm writing Python vector.py. So this should create a vector store path. Okay, pip install. Okay. Let's wait. Yes, over here I need to pass the embeddings. Yeah, I missed this, and this is going to be the LLM. That's it. And we have set up the API key. So the files vector store that we are storing is based on the OpenAI embeddings. Yeah, the code file will be shared. Means I'll be uploading all the files in the drive link, and the drive link will be shared. Towards the end of the session, the drive link will be shared. So this is just one part where I've created the vector store for the this PDF, right? So as you can see, there's a vector store created. The vector store and DB files. This is where I'll be fetching all this information from. So it generates the pickle index file and index files file. So as you can see, this folder means I've created using this code, alright? First, I'm reading the PDF, I'm loading it, then I'm splitting the data using a recursive character splitter, and I'm splitting it into multiple docs. And then from the files document, I'm creating for these documents, I'm creating a word embeddings and storing it in the vector store folder over here. So I hope this part is clear to everyone. Next, in the PDF chart, all right, okay, let's these dependencies anyway we'll be needing them. All right, we also need this part. We also need this part, all right. So this was just the first part. This was just the first part. So we have PDF loader, then we have recursive text character splitter, then we have files, then we have OpenAI embeddings. So I need a couple of other things. Then from LangChain dot prompts. From LangChain prompts, import chart prompt template. Okay, chart, I just need chart prompt template. Okay, no issues. Let's import this as well. I need chart prompt template. And I need to import Streamlit. Import Streamlit as ST. All right, then I need existing output parser. So these are a couple of dependencies that let's say might seem quite let's say unnecessary, but let's say as far as the chaining part is concerned, to chain let's say the rack part, we need to utilize them. All right. So over here, I'm setting up the output parser. I'll explain the code. Let me just write it once. Next, I'll show you the documentation as well. From LangChain code output, I think it is parsers. And then from output parsers, I need to import string output parser. And then I need to import runnable through. From LangChain codes dot runnables, I need to import runnable pass through. All right, see, these are the dependencies required. I might not be using a couple of them, but over here I've written these dependencies, right? So as you can see, first of all, see, I've created this vector store where I have splitted the data into chunks and then stored it in form of, let's say, vectors or word embeddings, right? Now, this is my OpenAI API key. I'll be writing this code in form of functions. So first of all, I need to load the data. All right, I need to load my data. So where do we have this data? So we have this data in form of the vector store, right? So over here, let's say I'm creating OpenAI embeddings. Then API key is going to be this OpenAI API key. All right, and then DB files path. What is the path that I'm utilizing? Path is the same. We do have the same path. All right, this is where the data is stored in form of word embeddings or in vectors after being splitted. And then see, in the previous file I've stored over here, I've stored it. All right, over here I'm saving it, and then over here I need to let's say load it. All right, we need to load it. So files dot load local. All right, and in load local, over here I'm passing DP files path. All right, we need to pass this, then embeddings. All right, so this is what it will capture as far as the embeddings is concerned. And then let's say to prevent some errors, over here I'm passing allow dangers deserialization true. Deserialization is, let's say, over here we have a pickle file, right? So we need to unpickle it. So we might end up encountering some errors. To overcome those, over here I've set up allow dangerous deserializations. So this is the first part where we are loading the data. Means we have stored the data in vector in word embeddings in form of a vector store, and using this function I'm loading the data. All right. So now my vector store is available to be utilized. Then let's define some prompt. So see, even the prompt I'm passing it as a string. All right. So let's define my prompt. So how should I define the prompt? All right. So let's see. You need to answer the question. You need to answer the question in the sentence as same as in the PDF content. All right, this is the general prompt that I'm passing. Is it clear? So, okay, let's consider it's going to be a multi-line string, right? Then over here I'm passing given below is the context and question of the user. Okay, so the sentence closes. I need to pass the context. This is the context. Next, I need to pass the question. This is the question. So see, additionally, we need to pass the context and the question. So context will be fed from this data. Context is going to, what is going to be the context? Over here, I'm just passing a prompt, right? What is the prompt? You need to answer the question in the sentence as same as in the PDF content. Is the prompt clear? Guys, is the prompt clear? You need to answer the question in the sentence as same as in the PDF content. All right. So what is the context over here? Context would be my vector store embeddings, right? And the question would be the user prompt. The question would be the user prompt. Are you getting this? So see, this does not end over here. Let's say if the answer is not in the PDF, means I'm customizing the prompt. All right, answer. All right. Over here, what is my response? Means this is meant to prevent the guesswork. This is meant to prevent the guesswork. If the answer is not in the PDF, then how am I supposed to answer it? I can't answer this based on my training. Is this clear to everyone? Guys, this is going to be my prompt. Now, the question would be the user prompt. Let's say in the when I'll be creating the Streamlit application, which we're already creating, and the context is going to be the data stored in the PDF. All right. This is what let's say retriever is going to utilize. Then over here, I'm setting the prompt, and the prompt is chat prompt template. All right, and then from template. And what is the template that I'm setting over here? The template is going to be prompt. All right, and we are simply returning the prompt. So just have a look. You need to answer the question in the sentence as same as in the PDF content given below. Is the context and question of the user. I hope guys this part is clear to everyone. Please respond. Guys, is this part clear to everyone? Okay, then I'll be creating two more functions. Next, I'm creating, let's say, load LLM. All right, and in load LLM, let's say, I just need to instantiate OpenAI embeddings, right? I need to instantiate the chart OpenAI. Chart OpenAI, I did not, just a minute, from LangChain dot OpenAI. From LangChain into OpenAI into chat OpenAI. This is what I need to copy over here. All right. So over here, I'm utilizing model is GPT 3.5 Turbo. So this is going to be my LLM, right? This is the LLM that I'm utilizing. Means there are a couple of other parameters. So this temperature is used to set certain randomization. And what is the API key? The API key that I'm using over here is this OpenAI API key. All right. Then I can simply return this LLM. So load LLM chat OpenAI, this is my model, and temperature is 0, API OpenAI key. API key is OpenAI API key. Then over here, I'm going to use a function called format docs. Format docs, what it is going to do, it is going to accept certain docs and then simply return. Means, okay, I'm giving, let's say, a few lines of space. All right, and then join. Maybe one if required, we can give 2 lines of space. All right, then over here I'm passing doc.page. This is how I'm utilizing. Over here I've utilized a for loop. All right. So each and every content in the PDF, I'll be formatting it like this with 1 line space. All right. Maybe you want to give 2 to 3 lines of space. See, this is going to be the primary prompt based on which my entire query will be based upon. Whatever user types the question, suppose this is my PDF, right? This is India budget. Suppose the user asks some question about the this PDF. So the root prompt or the main prompt that essentially guides the output is this. All right. So over here, I'm asking the ChatGPT 3.5 Turbo model to provide me answer in the sentence, same as in the PDF content. Provide me answer in the sentence, just the same as the PDF content. So what is the PDF content? So over here, I'm passing the context. And what is the question that the user will be typing in the web app? Okay, question is going to be fetched from whatever the user types in the web app. Context is this vector store. Context is this vector store which I'll be formatting, like this. Are you getting this? Are you getting this, Abhishek? All right. So, guys, this part we have set up, right? So, as just have a look over here, we have set up load data, then load prompt, then load LLM, and then format docs. All these parts are set up. Next, I'm going to create the Streamlit application, right? So over here, I'm writing streamlit.header, means I'm not customizing it as of now. And over here, I'm writing welcome to PDF, let's say, LLM PDF chatbot. All right. Then over here, let's say I'm setting my data, or let's say knowledge store. What is my knowledge store? So my knowledge store is this load data, right? This is where I'll store my knowledge store. Then what is my LLM? My LLM is load LLM. See, I've defined it in form of functions, and then I'll be chaining them. So to chain them, I'm creating, let's say, variables. All right. And what is going to be my prompt? My prompt is this load prompt. That is why I've created three functions. Load data, where my knowledge base is stored. Then load prompt, where I do have my prompt. So I'm trying to integrate everything over here. I'll show you the format as well. So over here, we utilize something known as LCEL. All right. Okay. So let me just write this, and I'll explain what LCEL is all about. Okay, let me show you in fact. Yeah. So over here, if you go to, okay, I'm just going to LangChain. All right. Just open LangChain. LangChain documentation. Not this one. I need this one. So over here, just have a look. We have n number of components in the LangChain, right? Over here, we have n number of components. We have LangGraph, we have integrations, we have LangChain, we have LangGraph, and then we have LangSmith. Now, essentially, this has come across as a very effective, let's say, framework, integrating multiple packages, even for deployment as well, even for deployment and monitoring as well. All right. Now, to understand certain basic concepts, over here we can go to build a chatbot. All right. And over here, let's say it is guiding us to create a chatbot. I'll show you the LCEL. Just a minute. Is it mentioned over here? Okay, tutorials. Yeah, over here, build a simple LLM application with LCEL. All right, see, LCEL stands for LangChain Expression Language. Over here, following the Pythonic syntax, LangChain has come up with LangChain Essential Language, where we can chain multiple components. All right. So over here, as you can see, we have created a couple of components, right? We have the knowledge store, we have the LLM, we have the prompt. So we need to chain it in form of context. Means first we need to pass the context. And what is going to be the context? Context we need to, let's say, retrieve. All right. Over here, we need to retrieve the context. And from this load data, and then we have to format it. Over here, we need to format it as well. Are you getting this? Guys, are you getting this? Please respond. Okay, let me show you what I was saying essentially. Then over here, I'm writing the query. Query is basically your question, right? See, over here, we have two parts, context and the question. So the question part is going to be the query. The question part is going to be your query. All right, so over here, I need to write streamlit dot text input. Over here, I'm passing a text input, and then over here, I'm writing enter your question. Enter your question. Okay, let me just write, I'll explain. I'll come to the explanation part. Let me just write this. So over here, clearly you can see four components. We have the knowledge store where we have the entire vector, let's say database, then LLM. All right, this is the model. So we are utilizing ChatGPT 3.5 model. Then this is the prompt. All right, this is the prompt on which our question will be, let's say, configured. And out of this prompt, the question is the query part. Are you getting this? So if user has entered a query, if the user has entered certain query, all right, then first of all, I need to apply certain similarity search. Similarity search based on what? I need to search the query with bias vector data store, right? And then over here, we'll be generating the retrieval object. Over here, we'll be generating the retriever object. So in similarity search, over here, I'm going to write, what is my knowledge store? This is going to be my knowledge store, right? And from the knowledge store, I'm applying similarity search. And I'll be applying the similarity search on what? I'll be applying similarity search on the query. Means the knowledge store will be searched for similarity against the user query, right? Are you getting this? Okay, over here I've named it similarity search. Let's call it similarity embedding. I'm calling it similarity embeddings. All right, and then let's say in the similarity embeddings, over here I'm writing twice dot from document and what documents do I need to look into? Over here, I need to look into similarity embeddings. All right, and what is going to be my embedding? My embedding is going to be OpenAI embedding, which I think this one. Guys, let me just complete and then I'll come to the explanation part. See, from the files vector store over here, means I'm passing, this is the, let's say similarity embeddings. All right, and this will be the data which will be fetched. This is the data which will be fetched based on this OpenAI embeddings. All right, then because I need to create a retriever object, I need to create a retriever object to implement RAG. So I'll show you. I'll show you where the LCEL part comes into picture. LCEL. All right. We have just seen this LangChain expression language. So it is a typical kind of a syntax. All right. I'll show you the documentation as well, how we are implementing this, which it is very much similar, but it's not exactly the same code because there you'll find a different example in the documentation. Over here, I'm utilizing a different example, right? So as far as the retriever is concerned, so this is similarity embeddings dot as the retriever. All right. So this is the RAG part. This part that I'm using over here is the RAG part. All right. This is the retrieval part. This is the retrieval part. All right. And then next we need to chain. Now, when we talk about the chaining part, this is where the LangChain expression language comes into picture. Over here, we need to define the RAG chain, right? This is going to be my RAG chain. Means, and the chaining syntax which I'm using, this is going to be the LCEL. LCEL, let's say syntax. Now, whatever I'm writing next is going to be the LCEL syntax. So first, over here, I'm passing a tuple. In tuple, the first element is going to be the dictionary, in which I need to set up the context. All right, and the context is going to be retriever. All right, and then I'll chain it based on the format docs. I'll chain it based on the format docs. So the pipeline operator is meant for chaining. All right, and they're all instances of runnables. I'll show you what runnable means. Then I need to pass the question. All right, and question is going to be fetched through runnable pass through. Question is going to be handled using the runnable pass through. So this is just the first part. All right, and next, so over here I've set up the dictionary. Then I need to chain it with prompt. Then I need to chain it with LLM, and whatever output it generates, right? Whatever output it generates, I'll be chaining it with string output parser to extract the relevant string information out of the output. All right, now this is referred to as a typical LangChain, which is written in form of LangChain expression language. This is written in form of LangChain expression language. And what is going to be my response? The response is RAG chain, and then over here I'll pass query. Over here I'm passing the query, and then streamlit dot write. I'll pass the response. All right, guys, this is my code. Let me check for any, let's say, errors. So welcome to LLM PDF chatbot. This is my knowledge store, and then knowledge store dot similarity search. I'm applying the similarity search on the query, which the user passes through the text input. Then I'm storing the similarity embeddings, and I'm applying files from documents, document similarity embeddings, and the embedding is going to be uh, OpenAI embeddings. The retriever is similarity embeddings dot as retriever. Alright, so this is where the retrieval part happens when it comes to RAG, and this is the RAG chain. Augmentation and generation, they're all part of this RAG chain. So context, okay, this is a spelling mistake. So context is going to be retriever, then whatever is retrieved, I'm formatting the docs. And what is the question? The question I'm setting up through runnable pass-through that takes this query, right? Runnable pass-through takes this query, and then we are passing the prompt and then LLM. So this is the part of the chain. This is the part of the RAG chain. Whatever is generated as the output, let's say, extracting the string output from it, and this is going to be the response. So over here, it need to take the query. This RAG chain has to take in the query. All right. So okay, now let me show you the documentation. Let's understand this with the documentation. So over here, build a simple LLM with LCEL. Prompt template for chaining it together with C. This is the chaining part, and that is an output of LCEL. Let me show you the tutorial. We have, yeah, see over here, build a retrieval RAG application, right? Over here, there's a link to RAG application. Let's see this. RAG, as discussed, is a technique for augmenting LLM knowledge with additional data. So LLM can reason about wide-ranging topics, but the knowledge is limited to the public data up to a specific point in time that they were trained on. This is what we have discussed. So if you want to build an AI applications that can reason about private data or data introduced after the model's cutoff date, all right, we need to, let's say, integrate RAG along with the specific model. So the objective over here is to the process of bringing appropriate information and inserting into the model prompt is referred to as RAG. Now, so first of all, what have we done? We have loaded the data, we have splitted the data, we have embedded it into vector embeddings, and now we do have a vector store. This part clearly we have implemented. This is the part we have implemented over here. Guys, please respond. I hope this part is clear to everyone. I hope this part is clear to everyone. Yes. Now, after this part, what is the next part? So loading, splitting, embedding, and storing is done. So as far as RAG is concerned, given a user input, relevant splits are retrieved from storage using a retriever. This is where I've created the retriever object. So whatever is the user question, it is retrieving the desired information from the vector store, and let's say adding it to the prompt, passing it to LLM, and then generating the output. All right, so this part we have already set up. Langsmith as of now is not required. See, these are the dependencies. Over here, it is utilizing, let's say, a blog link. This is the blog link from where it is utilized. Means this is not the same code as what I've done. Even over here, we are utilizing recursive character splitter. We are splitting it into documents. Over here for vector store, instead of files, they have used chroma. So this is where, let's say, see, this is the chaining part. This is the formatting part. We have also implemented this in the same format. Okay, so they have utilized, let's say, 2 lines of space. Okay, even we can modify this to 2 lines of space. All right. So this part is done. Then just observe the RAG chain. Observe the RAG chain. Is it similar to what we have done? Is it similar to what we have done? Observe this. Context is retriever. Then whatever is the context retrieved, we are formatting it. Means see there, when we're talking about vector store data, so the data is in form of embeddings, right? Data is in form of embeddings. So we are simply formatting it by giving 2 lines of space. This is just 2 lines of space for every page of the content. And then question will be fetched through runnable pass through. Means when we are running it, what is the question? The question is what is task decomposition? This is what is fetched over here. This is what goes through the query. All right. Then this question, this context and the question, this context and question goes to this prompt. Now in this prompt is comprised of both the context and the question. All right. And then this, let's say context and the context question along with the prompt goes to the LLM. And then whatever is the output generated after utilizing invoke, I'm just extracting the string output parser from it. I'm extracting only its string part. So let's understand this. Let's understand this part, all right? So over here, initially they are passing the indexing part, indexing split, okay. Then indexing to, then we have this. Yeah, just observe this part. What is prompt hub pull? Now this is a, let's say, predefined prompt, right? They have not created a custom prompt the way I've created. They do have a predefined prompt. Observe the prompt. Do they have the question and the context? Do you find a question and a context in the predefined prompt? Guys, there is a question and a context in the predefined prompt, yes or no? Over here, have we set up a question and a context? Over here in the prompt that we have set up a question and a context, right? So the context is the retriever, as in whatever is the information retrieved after scanning the, it's after extracting the similarity. After extracting the similar information, we are formatting it as well, all right? So this is the pipeline operator which is meant to chain. First, we are chaining context with the formatted document. Essentially, we are formatting the retrieved information. Then question will be fetched from the query. All right. This runnable pass through means whatever we are passing as the query. Means when you call this rag chain, so whatever you'll be passing as the query will be utilized in the runnable pass through. So they are all instances of runnable pass through. Means there are a couple of functions means like invoke that we can implement utilizing all of them. I'll show you. Just have a look. So when we use LCEL runnable protocol to define the chain that allows us to pipe together components and functions in a transparent way, automatically trace our chain in the Langsmith. So it means, let's say in Langsmith, we can visualize this chain as well, all right? Get streaming, async and batch falling out of the box. So let's try to decipher this part of the code. See, each of the components, retriever, prompt, LLM, they are all instances of runnable, means they implement same methods such as, let's say, sync, async, invoke, stream, batch, all right, which makes them easier to connect. They can be connected into another, let's say, runnable via the pipeline operator. LangChain will automatically cast certain objects to runnables when met with the pipeline operator. All right, format docs is to cast runnable lambda, means we are converting it to a particular format. That is how and why we are using the format docs. All right. Now, as we have seen, the input to the prompt is expected via dictionary with keys. We need to pass the context and the question. So first element of the chain gives runnables that will calculate both of these from the input questions. Are you getting this? So whatever is retrieved is formatted, and then it passes the question through the retriever, generating document object, and then format docs to generate the strings. Format docs is essentially required to generate the string output, right? Then runnable pass through passes the input question unchanged. So whatever is the input question, right? What is the input question over here? The input question is what is cache decomposition? And this is passed as the runnable pass through. Are you getting this? So chain invoke would build a formatted prompt ready for inference. And the last step of the chain are LLM, which runs the inference, and string output parser, which just plugs the string content out of the LLM's output. So that is how RAG is embedded or incorporated in the LLM. Are you getting this? Guys, this is the same part we have implemented over here. Now let's run this to check, and I'll show you the PDF as well. So India budget PDF, right? I think I've opened it. Yeah, this is the PDF. This is the PDF and it's in Hindi and English both. Means left side it's Hindi and right side it's English. So let's run this up first. Let's see if there are any errors that we might have overlooked. As of now, it seems correct. Let's run this. Over here, I need to first streamlet run pdf chart.py. And clearly, as you can see, we are in a virtual environment. So guys, first let's scan the document, all right? Let's scan this document. Okay, this is the budget, all right? Suppose I want to ask fiscal deficit is difference between total expenditure and revenue receipts. My first question is what is fiscal deficit? Okay, I think I'm getting some errors. Similarities so right. Over here, okay, this function over here is emitting error. Similarity search. Over here, I've used load data, so the data is loaded over here, and I'm applying similarity search on the query, right? I'm applying similarity search on the query. Similarity search. What went wrong? Guys, just give me a minute. Let me debug this issue. String output parser enable pass through. This is the OpenAI API key embeddings. Then the vector store, the pass embedding, about dangerous serialization. I can't answer this based on my training. And then chart from chart template prompt, and then over here we are utilizing chart. OpenAI model is GPT 3.5 turbo, temperature 0, API key, LLM, and then we are joining it with i.page content for I inbox. Then my knowledge store is the loop data, right? So if I do get a query, if the user enters a query, then I should get similarity embeddings by knowledge store. This is knowledge store similarity search on the query. Then similarity embeddings files.com documents. Document is okay. I need to pass this. It is the same thing. Similarity embeddings, and embedding is OpenAI embeddings API key. Retriever is similarity embeddings as a retriever. RAG this seems correct. Then in the context, I'm passing a retriever format docs. Question is runnable pass through prompt LLM string output parser. Response lag chain. Okay, I forgot the invoke function. I forgot the invoke function query. Let's run this. None type object has no similarity search. Knowledge store. Okay. Knowledge store load data. What went wrong? None type object has no similarity search. Let's check this. Means I do have a I do have another application with almost the same code. If it fails, I'll show you that. Where is it feeling exactly? Line 88, sequential function, similarity embeddings, knowledge store dot similarity search query. Right, so somehow it's failing to extract the similarity embeddings, right? It's failing to extract the similarity embeddings. So over here, I've passed similarity search, document is similarity embeddings, and the embedding is OpenAI embeddings, similarity embeddings, knowledge store. Okay, let's check the vector database part of it. So this is the OpenAI API key, the OpenAI embeddings loader is PyPDF loader, India budget 2024.pdf. Alright, then loader, load, then recursive, character splitter, chunk size is 1000, and the chunk overlap is 200. Then as far as the split is concerned, text splitter, split documents, docs, then the vector store files from documents, and document is splits, and embedding is LLM. The embedding is LLM, which is this, and vector store dot save local db by spark. So then this seems correct. Why knowledge store is not able to fetch the information, similarity search. Okay. Guys, I'm passing the embeddings, and then we need to see these are the documents on which it is getting trained. Somewhere down the line, this is how we are loading. Right, first we are saving this part we have seen, then we are loading the embeddings, and over here it is utilizing the similarity search, right? Even over here it is utilizing the similarity search. So why is it not getting loaded? All right, guys, it might take some time. So let's do one thing. I do have this application created. So I'll just copy paste and show you. All right, let's new file. I'll call this PDF chart 2 dot py. All right, majority of the functionality is same as you can see. And if required, I can use this OpenAI API. That was a different API. Now it is the same as the one which I've used in the vector store, vector.py, all right? So it's the same API key. This should work. As you can see, it is the same code, right? It is pretty much the same code, except for the fact that over here I've utilized this one in PyPDF code. I've set up the name module part as well. So this is the API key. And where this is the API key. Where else we need the API key? Over here. So as of now, as you can see, guys, this is how I've set this up. And that's it. So this part of the code refers to that we are utilizing the same module, right? We are utilizing the same module. Let's run this. Over here, I'm stopping this. Debugging might take some bit longer. So over here, I'm utilizing this. Streamlit run by PDF chart 2. The path is different, right? It is vector underscore store. The path is different. It is vector store. This is what I've set up. Vector store underscore db files, right? Okay. So guys, as you can see, this is the budget. Fiscal deficit, just read the definition. This is how it is defined, right? And what we are getting. Are we getting the same response? Are we getting the same response? Yes. Okay. Now let's increase the complexity. Now the PDF I've chosen is it's not a simple PDF. We do have information present in form of tables as well. All right. We do have information in form of table as well. So let me ask. So what is the total expenditure of Government of India? All right, for 24-25. This is the information, right? This is the number. Okay, as of now, I've not mentioned the year. Is it fetching the relevant information? Expenditure of Government of India is giving some different information, right? 7836184. Is it present somewhere else as well? Is it present somewhere else as well? Effective capital expenditure. I think it must be present somewhere else as well. Must be present somewhere else as well. Okay. Let's try questioning something else. Sources of financial. Okay, let's do one thing. Let's ask this question. See, what are the sources is it listing? Market borrowings, security against small saving, short-term borrowings, market borrowings, securities against small savings. Are we able to find this information? So just try to understand the LLM along with RAG is capable of drilling down the tabular information from PDF as well. Yes. State Provident Fund, external debt. Yes or no? Explain sources of financial deficit and its amount. Okay, so it's not displaying the amount, right? Grand total. Okay, let's try to extract grand total of this grand total of sources for 2024-2025. See, even after that, let's say the state of perfection is not something we should expect. So, okay, grand total, what it is displaying 1472915, right? 1472915. All right, 147. Okay, see, this is the number it is displaying 1472915. Are you getting this? Means it is not generating any random number, even though it's not correct. This is what I was expecting. But as of now, what it displays is this number. All right. Okay. Now let's ask a completely irrelevant question. Let's ask. Now, by any chance, do you find this Question can be answered utilizing this PDF. As you can see, yes, even I've explored the graphs as well. Yes. Okay, let's query the graph. All right, trend in tax receipts. For RE 2324. All right, okay, let's explore these two. All right, let's explore these two. See, whatever I've mentioned for BE, and what is the next one? RE 2324, right? And RE 2324. Okay, so I need to see the percentage, right? Okay, let's okay, so what is the percentage contribution of direct tax and indirect tax? All right. See, percentage contribution of direct and indirect tax. Okay, 5.1 indirect taxes, percentage contribution of direct taxes 25.8 and indirect taxes 5.5. Okay, it is not giving the exact result, right? Is it possible that we have similar information elsewhere? Expenditure, while for RE 2324, the percentage contribution is 23.3 and indirect taxes 4%. That is not the case, right? That is not the case over here. I'm getting different data. Okay, let's try to explore something else. Explain composition in terms of contribution. Let's see. Okay, see, if this is spelling error, then that's an error on my part. Just have a look. Okay, let's the composition of expenditure can be explained in terms of percentage contribution as follows. Now, 11.1, 3.9, I don't see these numbers over here. Okay, let's explore for BE 2024-25. BE 2024-25. Are we getting the same numbers? No, where is it fetching these numbers from? 11.1 other grants, loans, centrally sponsored scheme. See, at least these names are correct. Just try to understand. To get these names, you have to drill down into the chart, right? These names are correct? Yes or no? Please check. Are we getting the correct names? Yes. Okay, and it's not just that. I can even query in Hindi. It's not, let's say, language. It is completely language independent, right? I can query even in Hindi. Just see. Okay, now I don't have the Hindi keyboard. Okay, so it is given 20.99 lakh crore. Lakh crore. Okay, let's try some mix for RE23. Okay, for 2022-23. See, over here it has fetched this number. For 2022 and 23, it has fetched this number. Okay, let me further augment this. Now, guys, let's talk about. Okay, now I think it is fetching information from a different chart, maybe. Definitely, it is not this chart. Okay, let's ask something contextually from this outside of charts in Hindi, all right? In Hindi. Let's drill down. Composition of transfers to states and union territories. The entire data is in tabular form, right? Do we have some context? And so there can be many charts related to even a single topic. So that might be the case. Okay, let's try to explore something else. Is it not getting popular? Okay. Okay, let me scroll down. Let's explore something else. Okay. Let's explore some other charts in case we will have some. Let's explore the English version of it. Let's summarize this. So guys, as you can see, this is the result that I'm getting. So when we are utilizing RAG, means definitely we have not reached perfection. There are, let's say, we are still getting errors, but definitely it's an head forward towards the optimization. All right. Are you getting this? Guys, is this clear to everyone? Please respond. Guys, is this clear to everyone? Please respond. All right. Now, because we are short of time, so I'll show you, let's say, how to implement this. The SQL part of the chatbot, I'll show you, just give me a minute. So this was just one application. This is PDF chat. I'll be sharing the files. Don't leave the session yet. And then over here, I'm creating another file in the same folder. Right, and this is going to be, let's say, SQL chat dot py. All right, guys, I'm utilizing an API key. Just observe the code and just try to follow along. We have already set up MySQL. Over here, I'm utilizing, let's say, LangChain provides SQL database and SQL database chain. Over here, the code is quite crisp and not much detail. Over here, I'm setting the OpenAI API key. This is the chat AI, chat OpenAI key. And this is my SQL URL. I'm utilizing a particular database, right? It's a very small database. Let's say over here we have very elementary tables like students, sports related stuff. And then this is my connection string, right? So this is my connection string. The root is the username. This is my password. This is the host. This is the port number. Just try to understand. This is username, password, then host, then port number, and then the database. All right. This is the connection string. So from LangChain utilities, I'm connecting to this, let's say, URI. All right. This is the connection string. So this is how I'm connecting it to the database. And then in the DB chain over here, I'm utilizing LLM, which is chat OpenAI. And over here, let's say by default, it's going to be GPT 3.5 Turbo. I'm passing DB and verbose is set to true. First of all, over here, I've used a function called LangChain chains create SQL query chain, right? So there are two things essentially. First, I need to convert. See, suppose I wish to query my database. So first of all, I need to convert the text to SQL query, and then I need to execute the SQL query, right? So both of the things I'll be implementing over here. Let me stop the server. All right, what I'm going to do over here, just have a look. In LLM chatbot, this generates SQL query. What it is going to do, it is going to create SQL query chain, then chain invoke, and then over here I'm replacing it, right? Then as you can see, I'm replacing it. I'm replacing backslash and we may end up encountering backslash. So this is simply going to create SQL query chain is simply going to convert your prompt into the SQL query. And then this retrieve from DB or query means we can fetch from query as well. For that reason, I've imported my SQL connector. But as of now, I'm just utilizing DB chain query. So the query that I'll pass over here will be utilized here. And then I'm passing the context. And then it is going to return the DB context, right? So first of all, over here, just have a look. I'm converting text to SQL and chat with database. So there are two steps. First, I'm converting text to the SQL and then I'll chat with the database. So ask the question about database tables. I'll pass the user question. User will pass the question. Then I can mention the question as the user question. If at all there is a user question, then it will simply generate the SQL query and then will generate the output for the SQL query. Utilizing this retrieve DB from DB or query. So let me run this. This is streamlit run SQL chart.py. Now guys, just have a look. Over here, let's say find all students. So there are two steps who belong to Delhi. This is my, let's say, query, right? Just have a look. Is this a SQL statement? Is this a SQL query, yes or no? Means I'm just wrapping it up. So the guys just have a look. Over here, it has generated the SQL query, right? Just have a look. And over here, I'm generating the output. These are the students because I've connected with a database and that is how I'm getting the response. So this is what we have discussed yesterday. All right. We have discussed about prompt engineering, the fundamentals, the definitions. We have discussed the, let's say, parts of prompt, context, instruction, examples, tone, variations, and constraints. And then we have different prompting techniques like n-short prompting from 0, 1 to few shots. And then we have rule-based, code-based, iterative, and chain of thought. Now to yield better results, we can club multiple prompts. Like let's say we can add chain of thought to role-based along with few shots. So that would yield better results. This is what we have discussed, and this was entirely done on ChatGPT, right? Now today's agenda is okay. So let's say OpenAI chat completion. All right. Then we have
Besides this, we'll look into Gen AI, the theoretical part, Gen AI and LLM. Then we'll set up OpenAI and LangChain. All right, we'll have a hands-on session on Pandas AI, and then we'll build a PDF with chart application. Means we won't be building an application as such on, let's say, Streamlit or Flask. Rather, we'll be utilizing Colab. All right, so this is going to be today's agenda. Is this clear to everyone? See, because we have a lot of things to cover. So the primary requirement over here is to set up an API key, and you need to have at least $5 credit balance. All right. Okay. So tokens we have discussed yesterday. As far as tokens are concerned, so one token is approximately 4 characters or 0.75 words, right? Now, these prompts consume the token, and that is how your credit balance receipts. All right. So prompting also, let's say, is we need to consider number of tokens utilized into account as well. All right. So just go to Colab. This is what we were working on yesterday towards the end. So let's continue with where we were. First of all, you need to connect to Colab Notebook. All right, and then you can install OpenAI. Now, is everyone familiar with how to create an API key in OpenAI? Have you guys created the API key? Guys, can I get a response? Have you guys created the API key in OpenAI? All right. And you do have $5 credit balance, right? Okay. The otherwise creating an API key won't make a difference. Then we are importing, let's say, OS and OpenAI. I'm checking the version. So the version that I get to see over here is 1.13. Recordings will be shared by tomorrow. The recordings will be shared by tomorrow. Class files will be shared, means the files, PPT, all the content will be shared by today end of the day, as in by today when the session ends. But as far as recordings are concerned, most likely by today end of the day or by tomorrow, because rendering will take some time. All right, so this is where you need to paste your API key. This is how you need to paste your API key. All right, so I'm sharing this in the chat. This is my API key. I would request everyone to use your own API key. All right, and in case it still doesn't work, it means that you'll have to make the payment. All right, so this is what I'm sharing. I'm sharing this in the chat, all right? See, that is what I'm asking. No need to use this API key, because anyway, after the session, I'll be deleting the API key, right? So it won't work after the session ends. I've created this API key yesterday, and I have the option of deleting it. All right. So that is why I'm asking you to create your own API key. See, the objective here is not to, let's say, force you to make the payment. The objective here is that, let's say, for learning purpose. All right. So for learning purpose, this is the bare minimum that you have to do as far as OpenAI is concerned. I wish and hope that, let's say, $5 credit balance works in your case. All right. So this is how you can set up your API key. Then yesterday we have created this function, right? So the function is, let's say, okay, let me change the name to chat. Over here in the chat, I'll be passing a prompt, and messages, I've created a list of dictionary where I'm passing the role as user, and the content will be the prompt. So this prompt will be used as the content, and the role that I'm assigning is user. Now OpenAI comes up with this chat completion functionality where I can pass a particular model. So the model that comes up by default, that is GPT 3.5 Turbo. We do have other models as well, but let's say if you're using GPT-4, that is again, you need to make a payment. And messages is this messages which I'm passing as the argument, and temperature decides the degree of randomness in the response. Okay, yeah, sure. I'll be sharing this code. All right, I've shared this. And this is the code as well. You can try this. Hmm. All right. So I've shared these two parts of the code. So this is the helper function that we'll be utilizing to, let's say, interact with GPT 3.5 Turbo, right? Now, yesterday, I tried this kind of a prompt, generate a list of 5 food joints to try in Mumbai. And the function that I'm using is chat. And this is prompt one, right? Okay, I did not execute it. All right, as you can see, these are the responses that I'm getting, and this is, let's say, some description about the food joint. Is this clear to everyone? Now, the same function will be utilizing to work with different kind of prompts. So far, we were using ChatGPT for the same, but now, as in this moment onwards, we'll be utilizing OpenAI chat completion to use it locally in Colab. Yes, see, you need to create API key like this. First, you have to go over here, go to OpenAI platform, openai.com API keys. And then over here, you can create a new secret key. Click on create a secret key, pass any name, click on create secret key. You'll find the secret key, the encrypted secret key over here. Just copy this and you have to paste it over here. You have to paste it over here. Now, just tell me, is everyone getting responses? Are you guys getting responses, or is someone getting the error? See, if you're getting the responses, it simply means that your $5 credit is being utilized. If you're getting error, it means you have to make the payment. All right, no error. All right, good. So in case, let's say if your $5 depletes completely, right? So what you need to do, you just create another Gmail account. All right, create another Gmail account and log in with, sign up with that Gmail account to OpenAI. So again, you'll have $5 credit balance, right? Here. Okay. Is the process of, let's say, creating the API key clear to everyone? So this is just one kind of prompt, right? Now we'll be exploring different prompting creativity. All right. So these are different things, let's say, that can be explored. Couple of these things we have explored yesterday. So we'll be exploring these things much more today. Next, let's try some. Okay. Now suppose I want to generate some structured response, right? I want to generate certain structured response. Okay. So just have a look. This is another of my prompt. Yes, you have to import OS. Import OS. You have to import OS in the beginning and OpenAI. First thing is to, let's say, install OpenAI. Then you have to import OS and then import OpenAI. Please check the version because let's say if you're using an older version, then this functionality will not work. You'll have to change this. You'll have to change this. All right. How many of you are getting the response? Guys, are you getting the response over here? All right, great. Now let's means I'll be sharing these prompts. You can try experimenting with these kind of prompts, right? Now over here, I'm asking a particular type of structure, and the output. See the way we are maneuvering with the prompts. Generate a list of 3 made-up book titles along with their authors and genres. Now you can use, let's say, forward or backward slash to separate a section. Provide them in JSON format with the following keys. So the keys that I want are book ID, title, author, and genre. JSON is another, let's say, format, data type format, where we can have dictionary like data, right? So I'll be sharing this chart. I'll be sharing this prompt in the chat. Try this. All right, so this is the prompt. Now, how am I supposed to utilize this? Like this. Let's say this is prompt 1. Okay, this is prompt 1. I'm calling this prompt 2. All right, and as far as the result is concerned, this is how we can utilize the result. See, what is my output? My output is a list of dictionary where I have book ID, title, author, and genre. Now this format is referred to as JSON format. Are you getting this? Guys, have you tried this prompt? All right, hopefully it's working, right? Now you want to generate different responses, try changing the temperature. You can change it to 0.2, 0.3, 0.7 and likewise. All right, let's experiment with another prompt. All right, now see over here, I'm utilizing a text. Yes, no temperature, yes, to some extent you can say random state, but over here we are not splitting the data, right? Here temperature assigns some kind of randomness to the response. Because it is getting trained on large amount of data, means as of now, this is what I'm passing. But to fetch this data, right? The background training that it has undergone, these models, that assumes a large amount of data. So out of those large amount of data, temperature is used to set some randomness to the response. Now we'll be trying some different approach. Means this is just one example. We'll come more to summarization part. Let's say I want to see text summarization. Means we are just exploring the capabilities, right? So just have a look at the prompt. So the text is about India and Maldives row. India has an India and Maldives issue, right? So this is the text, and let's say this is a news article, and I want to summarize it. Summarize the text delimited by triple backticks. See over here, I have passed. This is the triple quotes, right? So I want to let's say summarize it into a single sentence with maximum 70 words. And this is the prompt, and the prompt includes another string. All right. So this is how I'll be passing it. I'm sharing it in the chat. Just experiment this. I've shared it in the chat. All right, now what is required? Let's call this text1. Let this be prompt3. All right, okay, let's call this text3. Over here, I need to pass this, and then I can print the result. See, why we are, let's say, practicing these kind of prompts, because I want to show you the variation and the potential, let's say, that is involved behind OpenAI ChatGPT. What all things can be implemented as far as text-based prompts are concerned. And hopefully, if it works, we'll see some text to image based prompts as well. All right, so see over here, I've limited the characters that I want to see in my output as well, right? So what is the response? The recent controversy between India and Maldives has highlighted the appeal of Indian tourist destinations like Andaman and Nicobar, with the chief secretary boasting of the great beaches, adventure opportunities, and tourism facilities, stating that they hold a distinct advantage over other island destinations in the Indian Ocean region. Now, because we are utilizing GPT 3.5 for summarization, it just takes, let's say, a couple of lines of code. Now, think about implementing deep learning. So if you attempt, let's say, text summarization using deep learning models, maybe using, let's say, frameworks like TensorFlow or Torch or even JAX, it would take a lot of training. Without, let's say, the intervention of ChatGPT, it would take a lot of training and a lot of lines of code as well to implement text summarization without GPT-based models. All right, text summarization used to be, uh, it was something that was considered a good project maybe a couple of years back. But once we have this, let's say, ChatGPT and Gen AI based models, now all of these things require very little amount of code. All right, let's try the next one. Okay, just have a look. Now over here, this is some process to make the tea, right? Now over here, let's say each and every step is elaborated. So making a cup of tea is easy. First, you need to get some water boiling. While that's happening, grab a cup, put a tea bag in it. Now see, all these steps are sequentially assigned. So the first step is given. Once the water is hot enough, so this is, let's say, the sequence that is following, right? All right, let it stir for a bit. After a few minutes, take out the tea bag. So in a sequence, all these things are given. Are you getting this? In this kind of text, there is a sequence that is being followed. Now, what is the prompt? You'll be provided with a text delimited by triple backquotes. If it contains a sequence of instructions, rewrite those instructions in the following format. All right, this is the kind of input that I'm passing, and this is the kind of, see, in the prompt, I'm passing the context. What is the context? The context is utilization of this text. And what is the instruction? I want to rewrite these instructions in this order. Step 1, step 2, step n. All right, and if the text does not contain a sequence of instructions, then simply write no steps provided. Is this prompt clear to everyone? Guys, just check the kind of prompt that we have. Is this prompt clear to everyone? Can I get a response, guys? Okay, I'm sharing this prompt in the chat. All right, just try pasting this. Now see, it is not just the prompt that we are using, we are utilizing prompt based on some context, right? So context I've passed in a separate, let's say, variable, and then I'm utilizing this. So over here, what are we attempting? We are checking some condition, right? All right, this is the prompt. And then how to obtain the result? Let's call this text 4. This is prompt 4. And this is how we can come to the results. All right, just have a look. See, are we getting the output in a sequence? The way we asked in the prompt? Think about the potential capabilities that we have inherent in ChatGPT based models. Now, okay, let's change the prompt a bit. I'm changing the prompt a bit to see if it works with a different example, right? See, first let me just write the prompt and I'll show you. This was text 4, right? I'm making it text 5. This is prompt 5. Just read the text and tell me if you find a sequence. Guys, just read the text. I'm sharing this in the chat. Let me know if you find a sequence over here. No, clearly we can't find a sequence over here, right? Okay, so what was the instruction? The instruction is the same. If it contains a sequence of instruction, rewrite those instructions in the following format. Otherwise, we need to write, otherwise it should generate the output as no steps provided. All right, I'll be sharing this prompt. Just try this. See, what we are essentially learning is how to curate different prompts and how, let's say, precisely we need to craft our prompts. Try to understand the difference between these two examples. The prompt is entirely same. It's just the context that is changing, right? Clearly, team making is a step-by-step process. But over here, it just, let's say, means over here we don't have a sequence, right? It's just description of a scenario. Are these prompts clear to everyone? Guys, are these prompts clear to everyone? Means, are you getting the responses the way we are expecting it to? All right. Let's try the next prompt. Okay, I'm passing the same prompt which we attempted yesterday, right? So this is again few short prompting that we attempted yesterday. Okay, you're getting a different response, Kancana and Gaurav. Okay, either try rerunning it or change the temperature. See, prompt engineering is a continuously evolving field, all right? So we may end up getting hallucinated results as discussed. Next we have so this is my prompt. Yesterday we have worked on this prompt. All right. Now, not every prompt needs a context specifically specified in a separate, let's say, variable. Over here, there is no variable specified, and I'm running it. It's the same example which we have worked yesterday. I'll share this. Just try this. See, the point is when you're using ChatGPT, you won't be able to utilize it into our own, let's say, system locally. Means you have to either copy paste it. All right, not getting any response. Please check again. You can check it again. Check the prompt maybe check the variables that you have passed. All right, I'm sharing this. See, we can expect variations, right? We can expect variations even on ChatGPT. And see, a same question asked, let's say if I'm asking the same question, you're also asking the same question to ChatGPT, we may expect different responses. Let me know if you have attempted till prompt 6. So it's the same example which we were working with yesterday, right? Now, this kind of a, let's say, model generation, this kind of a model generation, let's say, would take a lot of time if we were to implement this using even deep learning methods. So this is where ChatGPT comes to the rescue, or let's say Gen AI models comes to the rescue. Next, we can, in a single prompt, we can pass multiple, let's say we can specify multiple tasks. How? I'll show you. All right, means multiple tasks. So what tasks am I referring to? Tasks, okay, just think about it. Task would be which part of the prompt? When we say that we are specifying multiple tasks, so which part are we emphasizing on? Is it the context, the instruction, the example, constraint, tone or variation? Guys, can I get a response? Instruction. Yes, absolutely right. So when I'm specifying multiple tasks, right? Essentially, I'll be, let's say, passing a single context or maybe few contexts, but multiple instructions. So as of now, we have worked till prompt 6. Then we have, okay, just read the text. I'll be sharing it as well. So let's say this is text 7, prompt 7, and this is the text 7. Okay, I'm sharing it in the chat. Now let's read the prompt. In a charming village, siblings Jack and Jill set out on a quest to fetch water from the hilltop. As they climbed, singing joyfully, misfortune struck Jack, tripped on a stone and tumbled down the hill, with Jill following suit. Though slightly battered, the pair returned to home to comforting embraces. Despite an, let's say, mishap, their adventurous spirits remained undimmed, and they continued exploring with delight. Okay, let's switch to Hindi. Just change this. Summarize, see, what are the tasks that I'm instructing? Or let's say, what are the instructions that I'm passing into the prompt? Summarize the following text delimited by triple backticks with one sentence. Translate the summary into Hindi. List each name in the French summary in the Hindi summary. Means you can use French as well. You can choose to have a different language as well. So over here, we are not just, let's say, summarizing. We are translating it as well. All right. So over here, summarization plus translation. Now, even for translation, if you want to perform translation using deep learning models, it would take a lot of efforts. All right. Even using TensorFlow, PyTorch, and JAX, it is going to take a lot of efforts, and let's say the training time would be high. But with, let's say, ChatGPT based models, it becomes much more easier. All right. So this is the first instruction. The second is to translate the summary into Hindi. Then each name, list each name in the Hindi summary. You can use a different, let's say, language, right? The one that you're comfortable with. Then output a JSON object that contains the following keys. Let's say this is Hindi summary and number of names. All right. So there are two names in this, let's say, short story. We have Jack and Jill. Maybe we can change. Let's change the name. All right, let's change the names. Okay, as of now, I think I'll have to make few more changes. Okay, let's stick to the original names. I'll have to make multiple changes. I'm using the original names, right? Okay, let's run this. So what needs to be done? This is result 7 is chat prompt 7, and then I can print the result 7. See, instead of JSON, you can expect, you can pass even a dictionary. See, this is the summarization. This is the Hindi translation. Then list each name in the Hindi summary. So we have two names, Jack and Jill. All right. And this is the JSON output. What is the number of names? There are two names. Have you attempted this example? Okay, just try this. Try this. Try this. It's working, right? All right. Okay, now I hope everyone has, let's say, attempted a couple of examples using their own API keys, right? So just have a look at the credit balance. Means there would barely be any significant impact, but just check. Check your credit balance. As in, we have not implemented something that requires a lot of tokens. So as of now, it's not reflecting, but maybe towards the end of the session, if you check, there might be, let's say, minor deductions, 0.0102 or something of that order. Means this is essentially two separate. This is just two separate. Okay, 4.99, yes. Means I'm passing the text as a separate single string. All right, means I'm highlighting this in the sentence as well, in the prompt as well. That is why I've used single text. It's not needed. You can avoid this as well as long as we are using the F strings. All right. So see, this was a free credit balance, right? So try to utilize it entirely for learning purpose. And once it gets depleted, you can create a new Gmail account. All right. Okay. So I hope, let's say, these kind of tasks we have implemented. Then let's explore a few more tasks. Okay. So for the same task, means this is just the Hindi equivalent. Okay, just have a look how we are expecting the output to be. Means for the same task, right? The output is same, but here, let's say I've passed numbers to the tasks that I need to generate. Now over here, I'm customizing this a bit. So this was text 7. So we'll be using text 7, but this prompt is 8. All right, and I'm passing text 7. So everything is same. I'm just changing this. See, your task is to perform the following actions. This is something we have already done. Summarize the following text delimited by. Okay, what is this delimited by? This is delimited by, this is not delimited. All right, it is delimited by triple backticks, right? All right, translate the summary into Hindi, list each name in the Hindi summary and output a JSON object. But this is my task and I want my instruction to be, let's say, to be displayed in this kind of a format. So text contains the summarization, summary contains the summary, then translation, then list of names in Italian summary. All right, okay, this is Hindi summary. And then output JSON with summary and number of names. Everything else remains same. What I'm changing is this. So I'll be just sharing you this prompt. The text is same, right? The text is same. All right, and then I'm running this. I've shared it in the chat. Okay, I have to pass prompt 8. See, this is the format in which we are getting the results, right? So we have summary, translation, names, and the output into the JSON format. All right. Just read the translation in Hindi. And in case you guys are not familiar with Hindi, use a different language, the one with which you are comfortable with. Use your own native language. Is this clear how we are maneuvering the prompts? How we are tweaking the prompts as per our requirements? Guys, can I get a response? All right, which language you are using, Arvind? Okay, Tamil. Okay. So in Tamil also we do have different kind of, let's say, we have different ways of writing the text, right? So maybe it is following one of the approach. Okay, let's try out the next prompt. Okay, this is what we were implementing yesterday. This is chain of thought. Not this one. All right, this is my prompt. All right, the problem we were facing yesterday, and this is, let's say, result 9. Result 9 is chart, and this is prompt 9, and then I'm printing the result 9. Number of names, num names is the total number of names. All right, num names is the total number of names that we can find in this text. So how many names are present in this text? We have 2 names, right? Jack and Jill. Clear? All right. Try this. See, again, we are getting the error. So ideally, what should be the output? 23,000 minus 20,000 plus 6,000, right? This is what we expect the output to be. But what are we getting? Minus 3,000. All right. Now, previously, when I attempted it, the only difference I made in this prompt was this. All right, let's call it prompt 10. Everything else remains same. I've only added this. Let's think step by step. Let's see if it works. Previously, it was working in my system. All right, let's check this. It's the same example from yesterday. Are we getting the correct result? Please see. Where is it? Means this is just to highlight that the summarization goes here. This is just to highlight a section, the way we do in, let's say, XML or HTML. I'm creating custom tags to highlight a particular section that the text part, the summarization of the text part goes here. All right, the summary part goes here. Now observe this. Is this not the same prompt which we have used yesterday? I was getting a different response in ChatGPT. Please check. This was the same prompt I attempted yesterday, which means the output of which was hallucinated. Is it hallucinating now? What is the difference between these two prompts? The only difference is let's think step by step. So the cue to keep in mind is, means if you're using quotes, try utilizing let's think step by step. Let's say prompt at the end. Just add this part of this sentence at the end. All right. Now, still, if it hallucinates, you can try clubbing quote with few shot. All right. So quote plus few shot means you can provide these kind of examples, and on top of it, maybe you can club it with role based. So the basic kind of prompts can be, let's say, handled, or basic AI hallucinations can be handled with the combination of these three: quotes plus few shots plus role based. All right, so I'm not sharing this, just add this part to the sentence. I've already shared you this. Clear? All right, let's try the next one. Okay, let's try this. Another example on quotes. This is prompt 11. All right, just read this prompt. Read this prompt. Means quote, for quote we need to write let's think step by step. Means you have to provide a reasoning based question. At the end, add let's think step by step. Now to make it few short means solve similar examples and add it before quotes. You can also provide a role that maybe you are a senior mathematics trainer. This is how these things can be clubbed. Clear? Quote we have discussed, right? Chain of thought. Few shots means providing few examples, more than one usually, and role based where we assign roles. So this same prompt was means we were getting error, as in I was getting error yesterday. Clear? All right, let's run this. Now, just read option 1 and option 2 and tell me what should be the output. What should be the output? Okay, in option 1, what do we have at hand? We have 1000 minutes, then half an hour train, plus 30 minutes, plus 10 minutes bike, right? And what about option 2? 800-minute bus, plus half hour train, 30-minute bike ride. Yes, let's see. Now, what are we getting over here? All right. Now, how to optimize this? All right, this is what I'm passing. Let's think step by step. Okay, and R train, right? So this is 60. See, observe the impact of just this one statement. Just observe the impact of this statement. When I executed it before, I did not pass the statement. Now, are we getting more refined answer? Yes. So the keyword for, let's say, COTS is this. Means you can further optimize this. What is the queue over here? Let's think step by step. Clear to everyone? Okay, let's experiment with this. Another example of COT. This was, let's say, prompt 11. Let's call this prompt 12. Okay, just read the prompt. I'll be sharing it in a while. Now, guys, this is the prompt. A juggler can juggle 16 balls. Half of the balls are gold balls and half of the gold balls are blue. How many blue gold balls are there? Guys, what should be the output? All right, let's see. All right. So with just this statement, right, we are instructing the prompt to think step by step. And let's say it is essentially displaying those steps as well. The way it is approaching the problem statement, right? Are we getting correct answer? Guys, are you getting correct responses? All right. Okay, let's try this. It's indeed a bit, it's a bit long. Let's check. Let's see if this works. It's a bit much. It's much more elaborative. Read the prompt. What is the prompt that we have at hand? So let's say a customer bought a T-shirt, let's say from some brand on 1st March. The customer saw that there was a discount, so he bought a shirt that was originally, let's say, $30 and got 40% off. Now I saw that I have a new discount for the shirts at 50%. I'm wondering if I can return the shirt and have enough store credit to buy 2 of your shirts. All right. So this is the objective of the customer. And what is the instruction? Now this is the customer's inquiry. And let's say the instruction is that you are a customer service agent. So this, what kind of prompt are we talking about? What kind of prompting technique are we utilizing? Role based. Absolutely right. Role based along with COT. Okay, let's see. So as of now, this is role based. Now let's read the entire instruction. We are a customer service agent tasked with kindly responding to the customer. Now, this is kindly responding is setting up the tone to the customer inquiries. The returns are allowed within 30 days. Today's date is, let's say, you can tweak the date. April 4th. There is currently 50% discount on all shirts. There is currently no discount. All right. On shirts. Shirt price ranges from, let's say, $18 to $100 at your store. Do not make up any information about discount policies. All right, let's see. So clearly we can see that the return is allowed till 30 days, right? Return is allowed within 30 days of span. Now, today's date is 4th, on which, let's say, the customer is inquiring. Let's see, means we can change the date again to check for a different variant. See, it is essentially answering in kind of an email, right? What was the tone that we set up? I understand your concern about the new discount on shirts and wanting to maximize your store credit. As per our return policy, the returns are allowed within 30 days of purchase. Since you bought the shirt on, let's say, 1st March, see, since you bought the shirt on 1st March, you are still within the return window. Is it the case? Is it the case? No. All right. All right. I've just added the queue, making it role-based plus cot. The majority of the instructions are followed, means the response was kind enough. Let's see. See, still we are getting, so you're still within the time frame to return the shirt. See, still we are getting the hallucinated results, right? To determine if you'll have enough store credit to purchase 2 shirts with the current discount. See, we are still getting hallucinated results. Now try experimenting with the prompt. Try tweaking your prompt as per your, you're still wrong. So try experimenting. What can be done to, let's say, correct this? Okay, sure. I'll be sharing the prompt. Now to make it few short along with this same prompt, it would require, let's say, more examples on along the same guidelines. So it will means we can implement it, however, it will take some time. So that is not what we are going to do. Means you can attempt it on your own. Somewhere down the line, the prompt is not able to track the dates, right? So can we instruct over here to track the dates? Means that is not the explicit instruction, right? Means we are expecting the chat GPT or the customer service agent to act according to the dates provided. All right, that is not the explicit instruction. Guys, please don't use annotations. We are expecting our customer service agent to be smart enough to, let's say, track the dates and follow the return policy. But even with COTS, let's say we are still getting the hallucinated results, right? Try tweaking this. Try changing this. Anyone who is able to correct this. Done. Good. What about others? Is it yielding the desired results, Shruti? Is it yielding the desired results? Neelam, are you getting the desired output? What about others? Guys, are you trying this? Yes, that is the response. Good. Okay. What changes you have made? What changes can be done? Year is not required. Okay. What else? All right. Make sure. Okay. I added March month. Okay. So there can be different ways, right? In the chart, I can see that there are multiple ways using which, let's say, this prompt can be rectified. Clear? So I leave it up to you to, let's say, modify this prompt. See, I've asked you not to use annotations. All right. Now let's look at a few more examples. Okay, let's see a few examples of iterative prompting, right? Now it's a very long prompt. First, I'll share you the fact sheet. All right, this is the context. Okay, so it seems the message is too long to be shared. Okay, I'll break this down. Okay, I'm just sharing means you have to store it in a variable, all right? Please ensure that you store it in a variable. This is the first half of the context. And then this is the second half. All right, now you have to store this context in a variable. Just copy it, paste it entirely in a variable, and then we can utilize it. All right, so as of now, we are working till, okay, this is the fact sheet, means this is the factual information about a chair. Let's say this chair is, let's say, a product about which we have some description. All right, so this is the general description. So there are different shell color and base finishes available with plastic back and front upholstery or full upholstery, right? Base finish chair is available with or without armrest, suitable for home and business settings, qualified for contract use. Construction. So this is the construction description. Then these are the dimensions. Options: soft or hard floor. Caser options, 2 choices for seat foam densities. All right, and there are a couple of other information provided. So this is the material: cast aluminum with modified nylon. Shell thickness, and this is the seat. Then the country of origin is Italy. All right, so just observe that we have a detailed information about chair description, right? Now, what is the prompt? Have you created the variable for this prompt? Guys, have you created variable for this prompt? All right. The function we are using is chart, and this is the result. All right, let's see. So what is the instruction provided? Your task is to help a marketing team create a description for a retail website for the product based on the technical fact sheet. Write a product description based on the information provided in the technical specifications delimited by triple backticks. All right, and so basically we need to, let's say, write some content on the website about this product. So this is just the general instruction. We'll be modifying this prompt, all right? So the fact sheet chair remains the same. We'll be modifying this prompt. Just have a look. So did we ask for any specific, let's say, details in the website? Marketing team to create a description for retail website, right? There is no specific instruction. It is just the general instruction. Now we'll be adding more specific details. And the result is also, let's say, long enough. All right, so over here, we don't have proper sentences at times. But observe the details that we have generated out of the prompt. So these are fully structured sentences, right? Now, how we are going to modify this? Okay, this was the first description. Now, the second prompt is, everything is same. The description is intended for furniture retailers. So should be technical in nature and focus on the materials the product is constructed from. All right, and the instruction is to use at most 100 words. All right, the fact details information is same. All right, rest everything is same. So what do we need to use over here? Chart prompt 15, and then we are using result 15. See, so now means we can check the length of the words. So you'll have to read the output to check if the given instruction is being followed. We have to focus more on the materials, right? Just check. All right, so we do have information about the material. Okay, sure. Okay, prompt 14 I've not shared. All right, I'll be sharing prompt 14. This is prompt 14. Means I'll be sharing this entire file. At the end of the session, this entire file will be shared. And this is prompt 15. All right, I've shared both the prompts, 14 and 15. Now we do have more options. I've shown you a couple of them. All right. Now, so as of now, this was also part of text summarization, but let's discuss more on text summarization and how we can extract, let's say, some particular details. Anyway, we have implemented one of the summarization approaches. We have seen how to summarize the text using prompt. Now, this is the product review, and this is the text. I'm sharing this in the chat first. Try this. All right, so we are talking about a toy, let's say for someone's daughter's birthday, and we have some details over here, right? So it's soft and super cute, and its face has a friendly look, bit small for what I paid though. I think there might be other options that are bigger for the same price. It is bigger than expected. Now, this is the details. Now we can extract particular details as well, as in this is the general summarization task. So just implement this. I'll show you what all things can be done over here. So this is result 16, and this is prompt 16, right? Just try attempting it. So this is the general summary. Done. Guys, have you implemented it? Guys, can I get a response? Have you implemented this? All right, great. Next, let's extract custom details. Now, what are we focusing upon? First of all, I'm limiting the words because here it seems a bit long. All right, this was the general summary. Now my objective is to focus more on the shipment and delivery details, right? So, okay, this is the result. Okay, I'll share this. Yeah, I've shared it in the chat. See, because we have focused more on shipment and delivery, but it felt it was slightly small for the price. They were pleasantly surprised by the early delivery, allowing them to enjoy their toy before gifting it. So the chart, let's say the prompt does focus on the delivery and the shipment as well, right? Okay, I'll show you another prompt. Delimited by most focus on aspects that are relevant to price. Okay, relevant to shipping and delivery, this is done. All right, let's say this is more about price. So even in the summarization, we can ask for specific details. All right. And share this, the only changes here. Extract information relevant to just a minute. Extract, okay. This is what I need. Yeah, try this prompt 18. Now we have explored how to set the tone, how to limit the words, how to utilize quotes. Price and perceived value, right? Slightly small for the price paid. All right. Now, is it just, let's say, one product that we can review? We can review multiple products as well. Okay, so I have a long list. I'll be sharing you one by one, right? Means we can perform, let's say, multiple summarization all at once. So these are reviews for multiple products. Just keep on pasting them, and we'll be using loop to summarize them. Okay, so it seems this is a slightly, this is too big to be pasted. As of now, let's work with, let's say, review 2 and 3. So we have these 3 product reviews, right? All right, so the first review is the product review, which we have used. Then this is the review for the standing lamp, and this is the third review. Now, overall, all the reviews I'm encapsulating in a list. Review 1, review 2, and review 3. All right, so now I'm having 3 reviews. Now, how to work with all of them? Like this. Guys, are you attempting this? Let's call this reviews. And so far we have worked till prompt 18, right? Let's call this prompt 19. So this is the general review, means this is the general summarization. You can extract particular details as well. Just try to understand the horizon of different, let's say, prompting activities that we're implementing. See, review 1 is this, the product review, as in the toy review which we had. This one. This itself is the review 1. Okay, this one, sure. Just a minute. Now, so far, it seems we have implemented around, let's say, more than 10-15 prompts, right? Check the balance. All right. Hopefully, you should see it some change. All right, now let's work with sentiments. All right, so with this, I'll share the prompt first. This is another product review, right? This is what we'll be working upon. So what is the review over here? Needed a nice lamp for my bedroom, and this one had additional storage and not too high for price point, and so on. Means we have a number of details over here, right? So this is how we are implementing this. This is the prompt. This is, let's say, prompt 20. What is the overall sentiment? The overall sentiment is positive, right? Is this clear? So this is the general review. Means this is the general, let's say, sentiment or the emotion extraction out of an entire review. All right. Can we customize this a bit? Yes. Have you attempted this? I've shared the review, right? Okay, I think I need to share prompt 20. Just a minute. Now, we are going to discuss specific emotion extraction, right? This is prompt 20. Prompt 20 I've shared. Now just see. Just observe prompt 21. Guys, observe the prompt 21. What are we expecting over here? We are expecting to identify a list of emotions that the writer of the following review is expressing. Format your answer as a list of lowercase words separated by comma. So I'm trying to extract multiple sentiments or emotion, right? Not just one. Let's see. See, the overall sentiment is positive, but within each sentence, do we have different emotions or sentiments attached? So the positive word that we are getting out, getting over here as output is essentially based out of these words, right? Happy, satisfied, grateful, and impressed. Now, how have we reached this conclusion, or how the model has reached this conclusion? We can even extract this. See. So this was prompt 21. Then we have, let's call this prompt 22. Just read the prompt 22. Okay, do I need to share prompt 21 as well? Just a minute. I'll be sharing 21 and 22 together. 20 I've shared, right? This is 21. And this is 22. Just try experimenting with these. Okay, just add E over here. So identify the list of emotions that the writer of the following review is expressing. Format your answer into two columns. I want the sentence and the emotion separated by lowercase words separated by commas. Are you getting this? So now I'm interested in identifying emotion attached with each sentence. Are you getting this? See, format your answer. Let's say as of now, we have obtained the output is in two columns, right? Can we return a dictionary out of this? All right. All right. Now let's try this. Means I just I've formatted the prompt so that I end up getting a dictionary. See, are we getting the desired output? Is this clear to everyone, guys? Are these examples clear to everyone? All right. Now, okay, I'm skipping few examples because we have a lot of other things to cover too. Okay, let's see one email writing example. All right, so this is the prompt that we have. Let's call this prompt 23. Just read the prompt. Is it clear? Okay, I'll be sharing this prompt. All right, so let's implement this. So basically, I'm expecting a humorous yet professional email to the manager saying that I'll be out of office. Usually, this is not the protocol which is followed, but this is just an example to demonstrate the possibilities that we have. See, what is the humor? Uh, are you getting a humorous response? So this is where we can set the tone. Are you guys getting some humorous responses? Guys, can I get a response? Man flu? Great. What about others? I think I've shared the prompt, right? Yes, the prompt is shared. See, observe the creative liberty that we are utilizing. All right, yes. So it's the same response, right? All right, means you can have, means opt for a, you can change the tone over here. You can change the tone over here, right? And experiment this. Okay, then. Okay, translation, I think we have seen a couple of examples. Okay, just have a look. And show you a couple of examples on translation as well. All right, let's call this prompt 24. All right, just have a look. In case there are minor spelling mistakes, so please correct them before finally passing the prompt as input. I've shared the prompt. Try this. See, even tone has a specific impact, right? Read the 3 sentences. Are you able to realize how powerful this, let's say, this innovation is? Just go through the output. Is this clear to everyone? All right. Another example of tone translation could be something like this. All right. This is the prompt that I have. And I'm trying to see what capabilities does ChatGPT provide in terms of converting this, let's say, chart to a business letter. All right, see the entire tone transformation. I think I've shared the prompt, right? Clear to everyone? All right, then okay. Besides this, let me show you one more example. Okay, let's try to. So this is where the let's say now we're going to generate an image from a text, right? So that requires an entirely different model. This would require an entirely different model, right? As of now, we have been using GPT 3.5. So that is limited to text-based responses in terms of maybe code or let's say some text-based responses only. All right, but if we were to use, let's say this. All right, so then you have to set, you've already set the environment, right? Environment key we have already set. Just try implementing this. So we need to use a different model. I'm going to use DALI 3, all right? So the response that I need to pass over here is what is the model that I'll be utilizing? The model that I'm going to utilize is DALI 3. All right. Now suggest a prompt. I'll be sharing you the size I'm passing as. Now, trust me, this is going to consume this is going to deplete your credit balance quite fast. But I just want to show you one example. Hopefully it should work. All right, and n is the number of images, right? N happens to be number of images, so it will not directly generate the image over here, rather it is going to generate a URL. So what have we imported over here? We have imported OpenAI, then client is OpenAI. All right, from OpenAI we have imported OpenAI in caps, and then client.images.generate. So the model that we are utilizing over here is DALI 3. Prompt is something that we need to pass. This is the size, this is the quality, and then it is simply going to generate an image URL. All right. So how to fetch the image URL? Let's call this. As of now, we have worked till response 25. Let's call this response 26. And then we have dot data dot URL. All right, first I'll be sharing this. Now write a prompt over here. You have to feed in a prompt. But before writing this, please ensure that you have written this part. Let's try something simpler. So just a prompt, text to image based prompt. All right, so just a prompt. Okay, so suggest a prompt using which we can generate a caption. Means I want to generate an image. All right, let's try this. Okay, this I think is going to be X. This is not acceptable. We have to pass X. All right. Bad request. Error code none messages, none of the following. 1024 into 1024. Okay. It's 1024. What went wrong? Okay, quality we have standard and HD. As of now, I'm going for standard. Hopefully this should work. See, we are getting a URL, right? Read the prompt. Now, if you're implementing this, check your credit balance. Means try a different prompt, all right? Try your different prompt as per your own creativity. See, this is nothing less than a, let's say, HD image. All right. Check this. Okay, I'll share it again. See, it is not about OpenAI, it is about client. You have to use it with client. Client is from OpenAI. I'll share this again. All right. First, you have to import this from OpenAI, import client. Now, this capability is beyond what, let's say, ML could potentially do. And what deep learning models take a lot of time to train and then generate, but still they wouldn't reach this quality. Means as of now, besides the transformer-based models, the conventional deep learning models have not been scaled to such extent. Observe the picture quality as well. Now this is because we are using DALI 3. You can use DALI 2, but the picture quality would further degrade. Now, if you have generated an image and if we check the balance, previously it was 11.26, right? Last time when I checked. Now it's somewhere close to 11.21. All right. Guys, this is clear to everyone. Have you implemented this? How to import client? Just you need to write these 2 lines of code, right? This is what you need to write. See, I've asked you to use Colab. Maybe you're using a different version. Your OpenAI, you're using a different version of OpenAI. If you're using Colab, this will work. Otherwise, if you're using VS Code, maybe you have to set up a virtual environment. Anybody, let's say, anyone has attempted this? Guys, have you attempted this? Anyone? I've shared the corrected code, right? I've shared the corrected code. This is the corrected code. All right. See, you can try a different, no need to copy the same prompt. All right, great. All right. But this is means we can set the tone over here. All right. It seems you have set a cartoon based tone. Okay, rate limit error means $5 is expired. Rate limiting error means $5 is consumed. Now create another Gmail account or you have to recharge it. Clear? Or maybe DALI 3 is maybe not, let's say, allowed for free limit. You'll have to make the payment to utilize it. All right, you can download the image as well, we can simply click and download the image as well. All right. All right. So guys, this part we have covered. We have seen how to utilize OpenAI chat completion. We have seen what are its potential, right? We have seen its potential in quite detail. Now we're moving on to the next part, which is the Gen AI. Means theory part, we have let's say around 10 to 15 minutes of theory, and then we can move on to the next section. So OpenAI chart completion, this part we have implemented. DALI 3, let's say, is not available with free credit limit, most likely. The Gen AI technology, majority of these things are paid. So the drawback over here is, over here we can only generate one image. Over here we can only generate one image per, let's say, per request we can generate one image. But with DALI 2 you can generate multiple images. But with DALI 2 the quality will be low. Yeah, switch to DALI 2, but the quality of the image might be low. All right, we can set the tone as well. Means it entirely depends on your creativity. All right, now we are moving on to this part. Yeah. So let's talk about the world of LLMs. All right. First, we have to talk about generative AI in general, or this is what is referred to as Gen AI, right? Now, what we can see over here that in the past couple of years, we have seen that computers have started gaining the ability to learn, right? Learn, think, and communicate just like we do. Now, they can do creative intellectual work that previously only humans could do. Now, this technology is referred to as generative AI. As of now, we have been working, let's say those who are familiar with machine learning, we have worked with discriminative models, right? The way we have, let's say, supervised learning, where we perform regression and classification, that we can refer to it as discriminative models. Under generative models, we can generate a number of, let's say, uh, data types of formats. So why do we have generative AI at the moment? So generative AI aims to provide intelligence as a service. Think about it. What is ChatGPT offering? What is Gemini offering? What is DALI 3 offering? Don't you think they are all offering intelligence as a service? Now, first we need to keep in mind that it is not perfect, as we have seen with a number of prompts, but it is adapting to improve at an exponential rate, right? The growth that we have seen in, let's say, generative AI based tools, let's say in just a span of 14 months, is, let's say, exponential. Now, generative AI is designed to create new content or data that is similar to the input that it was trained on. It can generate images, text, music, or other types of content. All right. So where do we picture this generative AI in this Venn diagram? Before Gen AI, we just had AI, machine learning, and deep learning, right? Now, deep learning, we do have separate subsections in deep learning where generative AI stands. So we do have generative AI, means deep learning is further divided into computer vision and NLP. And generative AI, let's say, has laid a solid foundation in the depths of deep learning. And in generative AI, we have something called as LLM, which is large language models. All right. So keep this in mind. Generative AI is a superset. LLM, let's say, is a subset. Are you getting the picture? Where does it stand in the, let's say, AI chain? In the top, we have AI. All right. Machine learning is its subset, followed by deep learning is the subset of machine learning, and Gen AI is a subset of deep learning, into which we can utilize LLMs. LLMs stand for large language models. Particularly, they are used, let's say, in the domains of NLP, natural language processing, where we have text and speech related tasks. Is this clear to everyone? Guys, is this clear to everyone? All right. Now, this is, let's say, this is what we refer to as the emergent capabilities of Gen AI. Now, what all things can be used as input? We can use text as input, image as input, audio as input, and video as input. As far as machine learning is concerned, most of us have covered, let's say, just text-based data, right? Or maybe tables as input, or maybe arrays as input. But now we have image as input. We can pass audio as input and video as input as well. Prior to, let's say, Gen AI models, let's say image classification on audio classification was, let's say, very well, we can implement these things using deep learning models based on TensorFlow, PyTorch, and JAX. But now with the onset of Gen AI, we have much advanced models with much advanced capabilities. So this kind of an architecture is referred to as multimodal architecture. Why we are calling it multimodal? Multimodal simply means this is kind of the pinnacle of innovation. Multimodal models, right? Multimodal model simply means, see, as of now, we know that all right, what do we mean by multimodal? We can pass some input and we do get some output, right? Now, in machine learning, so far what we have seen, the output is either, let's say, text-based or maybe tabular data or array. In deep learning, to some extent, we can, let's say, use images and audio, to some extent video as well, but training on videos consumes a lot of time and effort. But when we talk about multimodal architecture, we are talking about whatever to whatever models, right? Are you getting the picture? Have you seen, okay, just check this. See, now I'm assuming most of you are familiar with Sura, but in case you are not, just have a look. What are we dealing with? We are dealing with creating video from text. All right, I'll give you a couple of examples. Let it load. Now, of course, because means the model is evolving, and this is just the beginning stage, let's say, of the multimodal models. So just observe this. Read the prompt. Read the prompt, and just see the output. This is the prompt. See, prompt has to be detailed because you are instructing to create a video, right? Think about the amount of learning that goes in the background. Think about the amount of mathematics that goes in the background. And just look at the detailing we have. Means in the first glimpse, and let's say it seems it would be hard for even, let's say we do have some CGI and VFX based uh, occupations, right? Even they would find it hard to generate such images, such videos with such ease. So as of now, it's limited to only around 1 minute or maybe 30 seconds, that too without the audio. On top of it, see, this was around, when was it? This was around 15 February, right? Now we have okay. See, Google has introduced Genie, first ever image to game AI. This was just 4 days back. Think about the pinnacle of innovation that we have reached in just a span of 14 months since the day the ChatGPT was launched. That was around 30th November 22. Are you getting the picture? So in times to come, let's say machine learning and deep learning is just going to be the tip of the iceberg. Now, see, how did they get the face? It's all about the background mathematics involved. It's all about the hardware capabilities. It's all about, let's say, the coding that goes in the background and the amount of data that it has been trained upon. Think about the complex training that it has undergone. All right. So the most recent advancement that I have seen or that I'm familiar with is this one. Means you can check out this video. First ever image to game AI, right? So this is what we are referring to when we are talking about multimodal architecture. Whatever is the input, it can convert it into another format, be it image, be it text, be it video, be it game. All right. No. Now that will be extremely pricey. As of now, this was just launched. When was this launched? Sura. Sura was launched around 15th February. Are you getting this? So let's get back to the topic. So this is what is referred to as multimodal architecture. Now, what are LLMs? LLMs essentially stand for large language models. They are the foundational machine learning models. And in the background, they are used deep learning, transformers, algorithm to process and understand natural language. Right. So LLMs are mostly used for, let's say, natural language or text-based tasks, be it translation, be it summarization, be it sentiment analysis, be it, let's say, speech to text conversion and vice versa. So these models are trained on massive amounts of text data to learn patterns and entity relationships in the language. Now, let's say in the year 23 and onwards, we do have, means n number of job opportunities are, let's say, sprouting in terms of that are LLM based. All right, LLMs can perform many types of language tasks such as translating, analyzing sentiments, chatbot conversations, and much more. All those things that you could have, let's say, that you might have thought regarding your projects with respect to maybe machine learning or deep learning. If it is text based, it can be implemented using LLMs for certainly. All right. They can understand complex textual data, identify entities and relationships between them, and generate new text that is coherent and grammatically accurate. Now, the fundamentals behind LLMs, what do they enable? So LLMs enables computers to understand and generate language better than ever before, unlocking a whole host of new applications. Prior to LLMs, let's say the foundation behind LLM, or the what should I call it? Let's say, yes, let's essentially call it the foundation behind LLMs is the transformers model, right? So we have transformers and the attention-based models that are used in the background of LLMs. So when we talk about deep learning models that are really good at understanding and generating human language, we are highlighting the capabilities of transformers. So now transformers, just let's say technical discussion on transformers would take around 4 to 5 hours. That is the bare minimum that it takes. All right. So that is a highly complex state-of-the-art neural network architecture invented by Google. Now, what made transformers architecture so powerful was the ability to scale effectively. Now, transformers came into picture in 2017. All right. So they are allowing us to train these models on a massive amount of text-based data. Now, what made LLMs so powerful is the fact that one model can be used for a variety of tasks, like chat, copywriting, translation, summarization, brainstorming, code generation, and a whole lot more. Now, these are certain open source LLMs that we have. I can show you. Means as of now, I've mentioned just a few. We have Bloom, Falcon, Llama 2, Mistral 7B, Olmo, Gemma. I'll show you the entire list. These are the list of open source LLMs. All right. So it all started with T5 in 2019. Then we have UL2, then Cerebra's GPT, then Pythia, Open Assistant. So just observe the license as in the proprietary or the ownership. So all these models were developed by Apache. All right. Then MIT came up with Dolly. Then we have a variant of GPT. All right. Then Blue. Then we have Fast Chat, H2O GPT, Open Llama. So Llama and Llama based models are from Meta. All right. We have Falcon, that is again from Apache. Then we have Llama 2 again from Meta. All right. Mistral 7B means GPT based models. Let's say GPT 3.5 and GPT 4, they are from OpenAI. Mistral 7B is again from Apache. All right. Then Olmo is from Apache, Gemma is from Google. Are you getting this? Now, if we talk about the hyperparameters, so we are talking about billions. Just observe the parameters. We have billions. The unit over here that we're dealing with is billions, right? We have billions of parameters. That is why, let's say, it's quite difficult to directly utilize them. Rather, some kind of quantization, bit quantization is required if we were to load this entirely and utilize this for our models. All right. Now, to implement these LLMs, we have two primary frameworks. One of them is LangChain. All right, and the other is Llama Index. These are two essential frameworks for implementing LLMs, right? Are you getting this? So we have seen how to use OpenAI, right? Now we'll be utilizing OpenAI along with LangChain and implementing the PDF app. Not as of now, but in a while. So let's get back to the PPT. All right, now what are the different types of models that we have in GenAI? Text-to-text models, we have GPT 3.5, GPT-4 Bard. Text-to-image models, I've just shown you DALL-E, right? DALL-E we have implemented as well. So GPT-4, Gemini, DALL-E, Stable, Diffuse, and Midjourney. Text-to-audio models where we have Whisper, Poly, Mari TTS. TTS is again text-to-speech. Then we have text-to-video. I've just shown you what Sora is capable of. Then we have image-to-image models where we have Stable Diffusion, image-to-game, just launched 4 days back. Then multimodal model architecture, we have GPT-4 Gemini. All right, and believe me, the list is going on and on at an exponential rate. Every month, some or the other, let's say LLMs are sprouting like mushrooms. Every month, some or the other LLM is, let's say, is launching. All right. So the rate at which, let's say, the AI intelligence is growing, it's much more faster compared to what we can grasp. But eventually, if you miss out on this train, then it will be let's say, it will be hard to catch up at a later stage. Now we'll discuss about some applications of LLM and then we'll come to the coding part, right? So clearly, when we are talking about LLM capabilities, so chatbot is something that every industry kind of uses, right? So when we are talking about chatbot, we can utilize it in telecom, banking, insurance, airlines, all right? So LLM powered smart agents, we do have something called as agents, right? As far as LLMs are concerned. So we can utilize these agents for customer inquiries in any written or voice channel, virtual assistants to guide users in resolving connectivity issues using images and video. We have seen how the customer service agent would reply, right? Try to recall, we have just implemented how the customer service agent would reply. So suppose user enters any, let's say, kind of assistance or help, maybe in a product delay or some kind of refund related issue. So we can generate chatbots to handle these kind of issues using LLMs. Are you getting this? Now, banking and insurance companies are utilizing this for automation of processes that require analyzing large quantities of documents. Financial AI advisor, LLM-driven financial advice. Suppose we want to analyze stock portfolio. All right, we want to analyze mutual funds. So we do have these kind of apps these days, but they are further getting refined using AI. All right, Gen AI tools. Okay, have you guys seen in Swiggy and Zomato? I think means I've seen in Zomato. If you're using the gold membership, they provide a Gen AI based, let's say, search. As of now, previously, how have we been searching Zomato? Let's say either we search for the food product or the restaurant, right? But if you have been using the gold membership of Zomato, you would have seen something like we can search, let's say, foods rich in protein. All right. We can search something of that sort and it generates the response. Has someone tried it? Guys, have you tried this? Can I get a response, guys? No means, see, this was not meant to make you buy the gold membership from Zomato. The objective was to, means I think you might have seen, couple of you might have seen, okay, no issues. So these kind of capabilities, let's say these apps are generating, right? Means these apps are incorporating Gen AI based applications into their own, let's say, services. Then we have insurance. So automate, let's say, claim processing with image recognition to access damages, precise risk assessment, LLM generated personalized policy recommendations. All right, based on customer's profile. Then in airlines, we can deploy virtual assistants for efficient customer service and offer personalized travel solutions, right? Image recognition for regular maintenance and safety checks. All these things, let's say we can tailor with LLMs. Then we have retail, mining, and healthcare. All right, we can enhance the shopping experience with personalized recommendations. As far as mining is concerned, we can implement LLM for predictive equipment maintenance, monitor safety conditions, etc. And as far as healthcare is concerned, we can assist doctors in diagnosing diseases with medical imaging analysis and helping doctors to interpret medical images and reports for quicker diagnosis. All right. So these are some, let's say, fundamental applications. Then as far as entertainment is concerned, LLMs can generate and recommend content based on mix of user preferences and behavior. Means we do have recommendation systems, but they are far more superior than recommendation systems. All right, LLMs can create immersive learning experience by combining text, images, and audio, right? Yesterday, if you remember, we have worked something on this. Yesterday, we have worked on this example, right? So just tell me, this kind of prompt, does it enhance the learning experience? Yes or no? Or this kind of prompt, should it enhance the learning experience? Yes. So this is how, let's say, means it just, as of now, it's text. And as of now, these, let's say, Gen AI models are paid. But eventually, let's say, maybe couple of years, couple of months down the line, or maybe couple of years down the line, their prices would slash. All right. So it's high time to get our hands dirty with not just Gen AI prompt engineering, but LLM as well. All right. Now, a couple of things are paid. So of course, means not everyone, let's say, would like to pay for learning, but uh, means it's entirely your choice. But I would recommend, let's say, at a minimal cost, if few things are available, you should invest your time to learn these things, right? Then what else do we have? Healthcare, we have seen. Now geography, LLM shows strong performance in geolocalization in urban areas and text extraction from historical maps, right? But let's say at times it struggles with natural landscapes. But it is still evolving, and the let's say the rate at which it is evolving, as discussed, is exponential. All right, now it can assist doctors with personalized treatment plans. All right, now these are a couple of applications. Now let's set up LangChain and OpenAI. In Colab, we can set up even over here. Means I'm just showing you the setup. So this part we have implemented, right? Okay, let me close this. Okay, I'm closing this already. Just open a new Colab notebook. Now, if I were to implement LLM, so we can use either LangChain framework or we can use OpenAI, right? So over here, I'll be utilizing a different version of OpenAI that is compatible with the LangChain. Means the other version is compatible, but I'll have to check the code. So just start with installation of OpenAI and LangChain. Just a minute. Let's set up this. We can use the same API key, the one you have created over here, right? We'll be using the same API key. The same API key works over here. Means we do have API keys from, just see how drastically it has reduced. All right. We can use the same API key. Means we do have the option of creating API keys from Gemini, from, let's say, Palm and Llama Index, Hugging Face. We do have those options as well. So as of now, we are talking about LangChain. All right, LangChain application means first we'll discuss Pandas AI and then we'll come to the LangChain in the end. So to install means that we'll do it in a different notebook. So the version that I'm going to use is, means if you use the same version, we'll be on the same page. Otherwise, we'll have to look for the corresponding functions, because there is some functionality change. If I'm using OpenAI 0.028 and previously I've used in this file, I've used OpenAI 1.13, right? And then I have LangChain. Just install these two. Okay, so in case you are getting this error, then you'll have to check for the functions. It's OpenAI. This is a spelling mistake. It's OpenAI. All right. Means we'll be using same API key, right, for both the tasks, using Pandas AI and for the PDF with chat with PDF application. Now is it downloading? All right. Means all these files will be shared. This entire folder will be shared with everyone. All right. So this is just the basics. We have set up the installation. Now we might need to use this. Means you have to write. Okay. Now what all things do I need to import? Over here I need to import. See, but for PDF chat application, we'll be using a different version, right? I just want to show you a couple of functionalities for which I'm using this version of OpenAI. For PDF with chat, we'll be installing OpenAI normally, the way we did previously. All right. Just install these dependencies. All right. As of now, this seems sufficient. And we'll copy this. We need to copy this. All right, just install these dependencies. Means we do have a couple of more dependencies. I'll be sharing in the chat. This is clear to everyone? So which version are we using? We are using 0.028, right? All right, now we need a couple of more dependencies. From langchain dot prompts, import prompt template. All right, as of now, just it seems one example would be good enough. Then let's call this the template name. Yeah, sure. Means I've shared it in the chat. Now this is my API key. You have to use your own API key. And in case you have created an image, so most likely just check your credit balance. Okay, just have a look. Means in the beginning, we started with this. This is what we have installed. All right, then I'm using this. All right, I'm checking the version and then I've imported this prompt template, right? I'm using this prompt template. So as the name sounds, so we can pass a prompt template over here, right? Now inside prompt template, I'll set the input variables. Means you can check the documentation. LangChain provides a very good and decent documentation from where we can, let's say, study. All right. Maybe we can pass input variable at a later stage. Just think about a prompt. or let's say third line of code. Which one? Means these are just the dependencies. This is how I've set the OpenAI API key. You need not check the version. All right, that is not required. All we need as of now is this prompt template. All right. Clear? All right. This is my prompt template. So if I print this, let's see. All right. This is the kind of template that I've passed. So this is the input prompt, right? What we have as of now, this is the input prompt. Now we want the output. So for output, there is one more thing that is required. These are the dependencies, means you'll have to check the documentation. It's a very rich documentation worth spending time for. All right. So using this LLM chain, we can extract, let's say, so this is the prompt that I've passed, right? Now, based on this prompt, I want to extract the output from the model. Are you getting this? Guys, are you getting this? There's one more thing that we need to write. Now I'm setting the temperature to 0. Okay, here it says deprecated. All right, as of now, that can be ignored. Hopefully this should work. So over here, I'm utilizing this LLM chain. All right, here I'll be setting the LLM to LLM. And what is the prompt? This is my prompt. This is going to be the result. Okay, sorry. See. All right. Means you can change the prompt, right? You can change the prompt. Yeah, this is the prompt. These are the dependencies. All right, see, so based on this genre type, what was my prompt? I'm writing the novel and sci-fi genre, suggest 3 innovative titles for this. Means in the in this prompt template, I'm passing the genre type as input, right? So this is what I've set over here. I'm invoking this result by passing this prompt. You can change the prompt. Let's say you can change the genre type. Maybe I want something. See, the titles have changed, right? Are you getting this? This is how we can utilize LangChain. This is clear. Means this is just a very beginner level example. There can be thousands of applications if you look into the documentation. And I've asked for 3, so it is suggesting 3. We can store this result in a variable as well, and then extract. See, this seems, and this is a dictionary, right? And then extract the particular results. Is this clear to everyone? Guys, is this clear to everyone? All right. Now, for some reason of some dependency conflict, I won't be able to set up Pandas AI in my Colab. I do have means I have it installed in let's say in Jupyter, but I won't be able to set up Pandas AI in Colab as of now. All right. You can try setting it up in Colab if it works well. Otherwise, we'll have to check how to resolve this. All right. So that is going to be our next topic. So we have seen how to utilize LangChain for conversation, right? Now, Pandas AI, let's say Pandas, we have all used Pandas, right? The entire data pre-processing part for any machine learning or deep learning model, majority of it we have implemented on Pandas. I hope there is no one over here who is not familiar with what Pandas is all about. Yes, everyone is familiar with Pandas, right? So we do have another dependency, which is Pandas AI. Open a new Jupyter notebook or maybe open Colab, and then you have to write this. Pip install Pandas AI. Let me know if it works. All right. I'll be sharing a data set. Just give me a minute. I'm uploading the data set. I'll share it with you so that we can work on it. Is Pandas AI installed? Means I'm using Jupyter, you can use Colab as well. If I use Colab, I'm getting some dependency conflict and I'll have to check how to resolve this. That might consume some time, which I don't have at hand. That is why I'm going to use Jupyter. See, this is the file that we are going to work upon. I'm sharing this file. You can use a different file as well, right? Means any CSV or Excel file we can work with. Yes, even I'm getting the same error, some blinker error. Means I'll have to check how to resolve this. That will consume some time. All right, so over here, see, this is the data set. Please download this data set. I've shared the data set in the chat. In Jupyter, you can install it like this. Means you'll be needing polars as well. You don't need to upgrade because I was using an older version. So I had to upgrade. Let's see. All right, these are the basic dependencies that we are all familiar with. Now I'm going to read this data set. See, this is the data set that I have, right? I'm having pizza ID, order ID, pizza name, quantity, order date, order time, unit price, total price, pizza size, pizza category. Okay, let's check the columns. Now, as of now, we are all familiar with different functions of pandas, right? At least we all know the basic functions in pandas. All right. See, whatever questions that we can frame on pandas, the same questions can be framed as prompts, and that is how we are going to utilize pandas AI. So again, even over here, we need to set up the same OpenAI key, right? So this is what we have. Now I'm importing pandas AI. Then again, we need this. All right, you can check the version. We have something called as smart data frame. All right, the same dependency. I'll share this in the chat. This is what I've imported. So it will only be imported once you have installed pandas AI. Are you getting this? Okay. So as of now, the remaining things you already know, right? Now, if you observe carefully, the order date, okay, I'll show you. Order date essentially should be in date time. Is it in date time? No, as of now, it's in object, right? What is the data type that we have? It's an object. All right, now, how to, let's say, we can solve these questions. But if we solve 13 questions, it will consume some time, more than what we have at hand. So I'll be solving around 4 to 5 questions just to demonstrate how to utilize pandas AI, right? Now for every query that we need to answer, suppose I want to find the shape. All right, find shape. So what we need to then, I'm writing df. This is what I've imported, right? Smart data frame. Now every question that we have with respect to our data frame, we can just write it as a prompt. All right. Are you getting this? I'll be using the same API key that I have. OpenAI, what went wrong? Okay, it's API key. All right, this is how I've set up the API key. And here in the smart data frame, I'm passing LLM. All right, see, I'm using smart data frame from pandas AI. This is how I've set up the LLM with the API key. Now we can query this. How are we querying this? Let's say this is result one. Result one is df PAI. Let's call it PAI1. LLM not found. Okay. Config data frame. LLM is required. What went wrong? df config LLM. Has anyone installed it? Guys, can you just try working it on your system? I'll share this. No, LLM, just try executing this in your system. Let me see. Let's see, when I was previously using in this system, I was not getting an error. Okay, I think I have to check the some dependency conflict. All right, so over here, this is not meant to be used, rather, we are supposed to use this. All right, now hopefully the issue should be resolved. See, so this is required. See, as of now, it's working, right? This is how we can query. So whatever you have as a data frame, just pass it into a smart data frame and then configure it with the LLM, which is set up with the corresponding API key, and then we can just query the data frame. So this is just a very elementary or the very basic query, right? Yeah. What went wrong? See, in case if it's a dependency issue, it will take some time to resolve. Other than that, dependency conflict will take some time to resolve. I'll be sharing this file, all right? I'll be sharing this file as it is. Besides this, what you can do, see, just check this. Just check this documentation. I'm sharing it in the chat. Can you tell what is the issue that we're facing, Arvind? What is the issue that you're facing? What about others, guys? Are you able to implement this? Guys, can I get a response? Are you able to implement this? All right, see. So what we require, okay, I'll share all the dependencies at once. This is what we need, all right? These are all the dependencies. And this is how we set up the API key. All right, next, we just need to pass a data frame in, let's say, in the smart data frame, and then we can question it, right? Okay, find null values. How to find the null values? We can just write the entire same code. All right. See, we are not getting any null values as well, right? Now, likewise, you can modify the prompt depending on your requirement. Now I'm going to solve some analysis based question. Can we change data type of order date? Yes. So guys, it seems that we'll have to extend the session till 2:15. All right, because we have one more task at hand. Now, what should be the prompt? I want to change the data type of order date. Over here, I've shown you order date is an object, right? So see, in case you have missed something, just follow along. Everything will be shared. How to change the data type of order date? What should be the prompt, guys? Order date is order date to date time. Now, if you check R3, R3 will be a data frame. Essentially, we are getting a data frame. Now, for R3, if we check the result, are we getting date time? See, even with data analysis, we are entirely interacting with prompts, right? Whatever manipulation that we are seeking, we are passing it as a prompt, just like a question or instruction. Here, now, which one do you want to implement? Okay, let me show you one very basic one. Top 5 orders with highest total price. Remaining questions, you'll have to attempt on your own, right? Means I'll show you a few more examples. Top 5 orders with highest total price. So we do have a total price, right? Top 5 orders. So basically, I'm seeking the order ID. This is the order ID. And as you can see, single order contains multiple pizza orders, right? Single order includes multiple, let's say, different varieties of pizza. Are you guys following along? Guys, do we have students who have installed Pandas AI? Can I get a response, guys? How many of you have successfully installed Pandas AI? Is it working in your system? I've shared the code. Is it working in your system? All right. So we were to implement top 5 orders with highest total price rate. So what should be the prompt? Can you suggest the prompt? Okay, as of now, I'm just writing this. Find top 5 order ID with highest order ID wise. All right, highest total price. See, I'm getting order ID wise total price. And because I've mentioned highest, so are we getting the result in descending order? All right. See, in Colab, I was getting some blinker issue that I need to spare some time to resolve it, right? That is why I'm using Jupyter. And check the version. There are 2 versions of Pandas AI. In case someone has, let's say, previously used it, then the version would be. The version that I'm using is 2.0.2. Now, in case you have attempted installing it maybe a couple of months back, then you'll have to upgrade. Because I installed it a couple of months back, or let's say 7 to 8 months back, so I had to upgrade it. All right. Now, which other question do you want to implement? I've shown you how to implement the basic analytical queries, right? Are you getting this? So we need to pass the original data frame, and then accordingly we'll get the result. Okay, I'll show you another example. Think about it, just observe the columns. Yes, yes. Means apologies that I won't be able to spare time for resolving the dependency conflict because we have limited time at hand. Observe this. In this data set, as of now, we have pizza ID, order ID, pizza name, quantity, order date. Order date, if we check, means I've checked it. So as of now, just believe me that all the order dates belong to the year 2015. All right. All the order dates belong to the year 2015. So what I want is I want month-wise sales. I want month-wise sum of sales, right? Order month-wise total price. Here, as of now, I've computed order ID wise total price. Now, order month is not existing feature of the data frame, right? Yes or no? Order month as of now is not a feature of the data frame. So we can even, let's say, extract this. How? Let's see. So the same template. Yeah. Now suggest a prompt. Suggest the prompt. Guys, please suggest the prompt. Can I get a response? Guys, can you suggest the prompt? Order month-wise, total price. See, we are getting months 1 to 12. This is the total price. Now, is it means this is a simple group by query, right? But is it just limited to, let's say, just utilizing one column, or can we add another column? See, see, why would we identify outliers in pizza ID? Yeah. What is the issue? Daily. Is this clear? Now, do you want to work with any other question from here? Do you want to work with any other question from here? Okay. What is M1 percentage change? Can someone tell me what is M1 percentage change? Anyone? So order month wise total price we have already calculated, right? Yes, month on month, correct. So let's say this is 13. Yeah. Now tell me the prompt. What should be the prompt? What should be the prompt? All right. And order month wise total price and percentage change in total price for each month compared to the previous month total price. Let's see. See. So for obvious reasons, the first month would the change in first month would be NAN. Now whether it is means correct or not, that is something we'll have to check. See, it is decreasing, so I'm getting negative. It is increasing, so I'm getting positive. Then again a decrease, so I'm getting negative. So that part is seems correct. But manually we'll have to validate whether the calculation is correct or not in case we were to validate. All right. So in case you are getting a different result, so most likely the, let's say, means you have been subjected to a hallucinated result. Try modifying the prompt. All right. So I just wanted to show you that even with pandas, we have pandas AI, and with pandas AI, we can perform these kind of calculations. If you were to validate, we can validate this as well, right? Using pandas, we have inbuilt functions. So means besides utilizing these inbuilt functions, we can customize something like this. Is this clear to everyone? Guys, are these examples clear to everyone? Means the remaining examples, I'll leave it up to you as an exercise to attempt. All right, I'm going to upload this over here. Yeah. So this part is done. Now we are left with one more aspect, which is let's say building let's say chart with PDF using LangChain. All right, this will consume around next means I'll be using 15 to 20 more minutes. Apologies for the delay, but there were a lot of things to cover. All right, so just cope up for next around 20 minutes. So essentially what we'll be doing over here, what do we need to do first over here? Means of course we are utilizing LangChain. Just understand the steps, how we are going to utilize it. The first step would be reading a PDF. Over here, I do have a PDF, right? See, if we take a break, means we barely need 15 to 20 more minutes. All right, I'll wrap it up and then it's going to be a break. Just 15 more minutes of your cooperation. So the first step is going to be reading a PDF. All right, then we'll be splitting. All right, then we'll be splitting the text from PDF into characters. All right, so for this, we do have functions from LangChain. Then we need some embeddings. So this text from PDF, we need to convert it into embeddings. So those who are familiar with deep learning should be familiar with what, let's say, what embeddings are. So over here, we do have LangChain embeddings, right? Means we do have embeddings from OpenAI and LangChain. Now, from this embeddings, we need something called as a vector store. We need a vector store, let's say, to store these embeddings. All right, so we have something known as files. All right, we have something known as files. All right, FI stands for it's Facebook AI similarity search. All right, so using files, we'll be storing these embeddings. It also facilitates, let's say, similarity search and text-based clustering. Then we need to, let's say, use some LangChain based QA chain. All right, using the QA chain, we'll be fetching user input. All right, whatever question user has, let's say from any particular context with respect to this PDF. All right, utilizing this user input. Now, FICE is what will be used to search the corresponding context which is mentioned in the prompt. All right, and when the search result is matched based on the similarity search, we'll be returning the output. All right, so it's not a very long code. It's just that the couple of things needs to be aligned up, right? These are the things that we need to look into. Are you getting this? I'll just take 15 more minutes, all right? And then I'll be sharing this as in this entire folder. So this part we have, okay. Just create a new file because now we need OpenAI 1.1. So over here, we need a number of dependencies. Means in case someone is implementing parallelly, so for that, I'll be sharing this PDF. Guys, this is the PDF that we are going to work with. You're free to use a different PDF in case you have one. All right, this is the, let's say, notebook that I've connected to. And over here means you need to download this PDF and upload it to your Colab, upload it to your drive if you want to utilize this. Over here, I'm installing LangChain. I need OpenAI. Now there is something called a stick token. All right, this will also be utilized. Means this keeps tracks of tokens. All right, then we need files, and we need now this will be used to read the PDF. All right, means we do have options from LangChain, but as of now, I'll be using this. And I think there is one more dependency. Yeah, most likely this one, LangChain OpenAI tick token, file CPU, file PDF, and LangChain OpenAI. These are the 6 dependencies that we need to install. See, anyway, we'll be requiring this. I'm just copying this part of the code. All right, I'll be sharing this. This is what you need to install. Yeah, these are the dependencies. And most likely it's going to work. Now, please check your balance, credit balance. In case it has turned out to be 0, then we won't be able to implement this. Means I do have sufficient balance. All right, so it seems these dependencies are involved. So LangChain, OpenAI, tick token, files. This is for similarity search. File PDF for reading the PDF, and LangChain OpenAI for one of the dependency that we need. All right, now of course we need import OS, import OpenAI, import LangChain. All right, at least these 3 dependencies we require as of now. Now there are a number of other things. Okay, let's write all of them. So from LangChain dot text splitter, I need to import character text splitter. All right, OS I've already installed. Then from LangChain means you'll find very let's say elaborative documentation based on all these functionalities that I'm importing from the LangChain documentation. All right. All right, so this character splitter will be used to split the text. Load QA chain will be utilizing QA is question answer, right? So we'll be interacting with using load QA chain with PDF. And then I need this. This is by PDF to write. Means just let me write, I'll share the code. I'll share the code, this entire file will be shared from PyPDF, import PDF reader. All right, and then from LangChain dot LLMs, import OpenAI. All right, and we need files as well. So from LangChain dot vector stores. Means it would be better if you change the runtime. All right, means we're using GPU to speed up the processing. These are the dependencies. As of now, this is what I'm able to recall. I'm sharing this in the chat. All right, this is my API key setup. The same we have been utilizing since we have started using Colab for let's say GenAI operations. Then I need to, because I have this file over here, this file is present over here, right? So this is master class. So I need to, let's say, mount my Google Drive. All right, now as you can see, my Google Drive is mounted. So from here, I need to extract the location of PDF. This is where I do have my PDF. All right. This is the function and this is the path. All right. It's EDF, eds.pdf. EDS is, I think it's education system, Indian education system, PDF. All right. Now, what is the data present over here? So initially I'm assigning it as a, let's say, empty string for I, comma, page in enumerate. Because in PDF we do have multiple pages. See, we do have multiple pages over here, right? So this is what I'm utilizing. All right, so these are functions from PDF reader. This is how I'm extracting the content. So if at all I get some content, I do get some content, right? Then data, I'm adding the content to the data. I'll show you the content. See, this is my data that I have. This is the data from PDF. See, all right, this is the entire data. You can use a different PDF. Yes, so means it can contain images. Now you want to query the images as well, so that would require, let's say, some additional models. All right, that would require some additional functionalities, or maybe you need to use some OCR based LLMs. Means I'll have to check. I've not worked on those OCR based LLMs. If at all they do exist, in case we have some, let's say, text in images, we can extract those as well using OCR, optical character reader. So that would require a different kind of analysis. And these two can be clubbed. All right. So this is the data that I have. As you can see, the entire PPT data I've stored in a variable. What is the variable name? The variable that I'm using as of now is data. All right, next. I've shown you the variable. Next, we need to split the text. All right, so for this, we need character splitter, which I've imported over here. Character text splitter. It takes a couple of arguments. All right, now in character text splitter, I need to separate the text with \n. All right, what is the chunk size? Chunk size is the number of characters that I want to utilize. All right, for each sentence. So let's say I'm passing 800. In case I want to allow some overlapping. Now to have a look means if you want to look these functionalities in, or let's say these arguments in detail, you'll have to check the documentation. And there is another parameter, which is the length function. So length function essentially is length. And then over here, this is the text splitter. See, we are splitting the text because text as of now, we have a number of text. So we are splitting the text line by line, right? And maximum allowed chunk size that I'm passing over here is 800. We do have certain restrictions as well. All right, so you have used Mistral 7B, Rushabh. Have you tried OCR? Just explore how to work with OCR. Have you tried clubbing Llama 2 with OCR? Now explore the ways using which you can club these two. All right, this is what I need to split. All right, means in case you do have the code, you can share it with me. I'll look into it. And we have imported LangChain OpenAI, right? Yes, LangChain OpenAI we have imported. So as of now, we do have the character splitter as well, right? After character splitting, next we need to import from LangChain OpenAI, import OpenAI embeddings. So if you guys are familiar with word embeddings that we have in NLP, so this works in a similar fashion, but let's say this is much more refined. All right, so I've created an object of OpenAI embeddings. Then if I need to search the document, all right, if I were to search the document, so I need files, that is Facebook AI similarity search, and then from text. And what is the input that I'll be passing? This, and this is the embeddings. All right, now if I print this document search, I can show you that this is going to be a vector store. See, this is a vector store, right? This is the memory address. All right, we have imported QA chain. Yes, QA chain is imported. And there's one more thing I think that we need to import. From LangChain, OpenAI, import OpenAI. All right, the way we did in Pandas AI. But that was using Pandas AI. Over here, we need this. And QA chain is already imported. So we need to create a chain object where I'll have load QA chain. All right, over here, I need to pass this OpenAI. And then I need to pass chain type. Chain type essentially is the kind of search you want. So if I want to search the entire document, I'll have to pass stuff. We do have other options as well because I want my prompt to be searched in the entire document. So I need to pass stuff over here. All right. Now we are ready to query. So let's say our query is All right, this is my query. So basically, this is your query prompt, right? Now, how to search this? Over here, I'll be passing the document search. All right, see, we do have this vector store, right? What is this vector store? We do have this document search, right? So from this document search, I need to find similarity. All right, similarity search. All right, and similarity search, I'll be passing the query. Then in the chain dot run, what do I need to run this upon? What is my input document? The input document that I have over here is docs. All right, and what is my question? My question is Q1. Q1 is essentially the query. Then I can print R1. So first I would like to summarize this PDF. Sorry, 1200 is quite long. I should have used 200. See, we are getting the result, right? Now 1200 is quite long. So I'm refining the search. Now the same, these 4 lines of code you need to use. All right, everything is same. The only thing that changes is this. This is how we can search the PDFs. See, yeah, embeddings creation. This is where we have the embeddings creation. So guys, this is how to implement chat with PDF application. Now there are a number of things when it comes to LangChain, and essentially it requires, let's say, exploration on your own. If you look at the LangChain documentation, it is very long and extremely relevant documentation that needs to be worked upon. All right. Is this clear to everyone? Chunk overlap, in case we want the sentences to overlap, means there can be certain sentences that we do have overlapping, right? And for more detailed explanation, you'll have to check the documentation. These are certain parameters. Chunk size is the number of characters that we want to have in our sentence. Is this clear? So guys, this file is already present over here. Yes, we can say to keep some connections. Now, all these files are present over here. I'm going to share this entire folder with you guys. All right, all the files that we have implemented are present over here. All right, see, all the files are present over here. Pandas AI, chat with PDF, and hands-on OpenAI and LangChain implementation. Yeah, you can download all these files from here. So guys, I just take 1 or 2 more minutes of your time. I would like to have your feedback regarding the session. See, I can completely understand that I try to incorporate a lot of things in a limited amount of time. But still, I would appreciate if you can provide some feedback regarding this session in the chat. Meanwhile, what all things we have implemented, we have seen building chat with PDF application, data analysis using Pandas AI. Yeah, so I'm enabling the mute option, unmute option. In case you have some queries, you can unmute your mic and ask. And there's one more thing I would like to share with you guys. Someone asked this yesterday. Yeah. It's a very beautiful prompt engineering roadmap. Can share with you guys. Guys, please unmute your mic in case you have some questions. We can discuss them. See, the objective was to get you guys, so to give you guys some familiarity with prompt engineering and to show you the potential of Gen AI based models, right? Now in 2024, just machine learning and deep learning is not going to be enough for grabbing good ML and let's say ML and let's say rules that requires machine learning and maybe deep learning, right? You need to have some sort of familiarity with LangChain and LLMs and Gen AI based models. See, this is the roadmap. So these are different prompting techniques that we have covered. There are a couple of advanced prompting techniques as well that you can look into. Guys, can you provide some feedback as well? Can other students also provide some feedback? Now it's a humble request to everyone who has attempted this session to invest some time. Means you have to devote some time into learning, let's say, prompt engineering and Gen AI based models.
Hello, sir.
Yeah.
Sir, where are the opportunities of this prompt engineering and Gen AI?
Where are the opportunities as in?
Yes, sir. I am searching for that profile. Now I'm not finding it anywhere.
Means if you look at job opportunities in Bangalore and maybe Hyderabad, Pune, and to some extent in Gurgaon, you might end up finding it.
Okay. Sir, what are the basic requirements?
Basic requirements: machine learning, NLP, CV, Gen AI, prompt engineering, all these things clubbed.
Are these opportunities for freshers, sir?
Means that is entirely dependent on the caliber of the fresher. If you
Okay.
can propel yourself to such an extent that, let's say, you can cover LLM and couple of these Gen AI models, then definitely freshers do have a scope.
But sir, they do not entertain us as a fresher. They need experienced or
See, for a corporate employee, or let's say for a corporate institute to entertain a fresher, the fresher must have the desired skill sets so that he can be entertained, right? And the desired level of projects.
Yes, sir.
So based on project, based on your learning, based on your skill set, all those things clubbed with the right opportunity, let's say, bridges the gap.
Okay, sir.
Guys, anyone having any other question? I've shared this roadmap, right? Okay, I'll share it again in case I haven't. All right. So let's wrap up today's session over here. Anyone else would like to add anything or any question that you might have? And sorry for the delay in your lunch time.
Yeah, I want to extend a lot of appreciation for you and the students who have joined over this weekend. And I think it was a very well crafted, thought out session, very elaborated. So I'm very sure that these guys are going to make the best of learnings they had over this weekend. Thanks a lot, Utkarsh.
All right.
Yeah, if we do not have any more questions, we can close this.
So thank you guys. So let's wrap up this session, and the recordings will be shared maybe by today end of the day or by tomorrow. All right. Everyone has received access to the drive link.
Craft the future of AI interactions one prompt at a time. Like this video, subscribe to our channel, and comment with your most successful prompt below.